Lot of important chapters are there. We have divided this whole thing in the 4 parts, and each part roughly covers around 11-12 questions. And here we have some of the very scoring chapters actually. And you can do all these questions correct also in the examination. Already you have practiced. So what I have done basically, what we will do in this marathon, I have taken in text example of NCRT, I have taken solved example, exercise questions of NCRT, because for you it is not possible to do all the things right now. As well as from exemplar also, if some good questions are there, single correct, as well as VSA, very short type, out of that what they can make the questions. So I have taken some questions from there, important questions, and some of the questions I have left actually that we will ask in the your face examination. So if you are doing this thing correct, means this one you are doing perfectly, and you are giving your face examinations, your NCRT exemplar is going to be covered completely if you are not done by this time. Okay, and those who are done by this time also, they have done the NCRT, this is going to be the best revision actually. Quickly we can revise, because you know that if you have to read the NCRT from top to bottom, it takes a lot of time, a lot of efforts. So just okay, whatever the important points are there, either it is from the points to ponder, either it is from summary, all those things are taken in this PPT here. Because I prepared this separate PPT region was because when we open the NCRT, it takes a lot of time to switch from here to here. We need, so just taken that their screenshot and taken whatever the important things are there. Okay, so now I hope you all are ready. So I will say that take this thing very sincerely. One more thing that here, you know that first one we are going to have unit and dimension. Unit dimension, I don't have to say that is the important chapter. Already you know it is very, very important. Almost 2-3 questions are going to be there. In this, we are having roughly around 100 to 105, around 105 pages are there. Each page almost one point there. Somehow 1 point, somehow 2 points like this. So roughly we have, okay, in this one we are going to cover around 100 to 120 concept will be covered out of your means 11th class, half of the 11th. And at the end, okay, when you will be sitting your examination, means final examination I'm talking about, you will see yes, actually a lot of questions were from there. Only thing that you need to recall those things. So you need to revise also. Okay, this is the, because one time I will say, and I said, and if you don't revise, you don't recall those things, you will forget till the exam is there. Exam is not too far, but still 20 days are there. No? Almost I can say we might forget. So you need to recall also these things. So now let's start with the unit dimension part here. Okay. So we have first thing here in this one, 7 fundamental quantities are known to be everyone. Everyone knows these 7 fundamental quantities. I am not going to say that what are these, okay, fundamental quantities here. Everyone knows, you know, length, mass, time, electric current, temperature, no? Then your amount of substance, and then the luminous intensity. Everyone knows these are the symbols, and this information not needed. Okay, whatever is written here, no need of this thing. Okay, why no need of this thing? Because in this one some values are given. They are saying, NCRT is saying here, the values mentioned here need not to be remembered. Okay, if you see, the values mentioned here need not to be remembered or asked in a test. Okay, so no need to do all these things. Just these are the 7 fundamental quantities. Other than the 7 fundamental quantities, we have 2 more quantity. Okay, that you need to remember. Okay, given here. Okay, now in SI there are the 7 base units. Okay, if you read here in Okay, SI, there are 7 base units as given in table. Beside the 7 base unit, there are the 2 more units that are defined for a plane angle. Okay, plane angle as well as solid angle basically. This is the your plane angle, and this plane angle we are writing as simple, okay, arc by radius, and this one is known as your solid angle. Okay, plane angle unit is radian, and this one is the steradian. So these you have to remember, radian as well as steradian. 2 more units are there. Okay, this is the formula written here. You might have used these things in the electrostatics or somewhere, but here you will remember that 2 more we have in this one. There is the plane angle, okay, and solid angle, okay, that we can say d omega is the ratio of intercepted area of the spherical surface. Okay, so this is the dA divided by r square, and this is the your, here we can say ds, arc by radius. Okay, now unit for plane angle is radian with the symbol rad, while the unit for solid angle is the steradian, okay, with the symbol sr we use. Okay, both these are dimensionless quantities. Okay, they have unit. Remember, angle and solid angle. Okay, they have means here we can say they have unit. Okay, so we can say angle and solid angle. Okay, angle and solid angle. Okay, angle and solid angle have unit but dimensionless. Okay, but dimensionless. Okay, previously they have asked also this statement that they have unit but it was the dimensionless. You have solved the PYQ, you remember in the 22 I think this question was there. Okay, okay, now further, okay, this here just we have to remember. Then we got about the your significant figure, very important line from the NCERT. They have given these examples. You need to remember. In multiplication or division, the final result, okay, final result should retain as many significant figure as there in the original number with the least significant figure. Means if I summarize this one, what the summary, that whenever you are doing multiplication and division, then final result should have the least number of significant figure, because we are doing some your multiplication or division for the 2 numbers, no? So if you are having, then which number is having, like in this example, this one, this is having how many significant figure? You can say here 4 significant figures are there. Everyone can find 4 significant figure. In this one, how many significant figures are there? 3 significant figure. Your answer should be having whatever the density. Mostly you don't have to divide. You will answer based on the significant figure. Your answer should be having 4 significant figure or 3 significant figure. Rule is saying that least number of significant figure. Okay, your answer should be, okay, with the answer must be with the least significant figure. Okay, so in the multiplication and division, okay, consider least number of significant figure. In this number 4 significant figure, here 3 significant figure, my answer must be having 3 significant figure. So this is the answer. Mostly you don't have to divide. They are not asking your calculation, means they are not checking your calculation skills. So remember, whenever multiplication division is there, we need to consider least number of decimal. Okay, least number of significant figure, not the decimal. Okay, decimal we'll talk later on. So significant figure, here 4 significant, here 3 significant figure, answer 3 significant figure. If any of the number has the 2 significant figure, answer will be going up to 2 days. Okay, 2 significant figure. We have one more example here in this one. If the like this, okay, so this also is given, and I will go for this one. Okay, addition or subtraction. Addition or subtraction, whenever we are having, then we need to consider the least number of decimal places. Okay, least number of decimal places. So in addition or subtraction, the final result should retain as many decimal places as are the, okay, in the number with the least decimal places. Means whenever we are doing the plus or minus, okay, then you need to consider least decimal places. Okay, okay. Suppose two numbers you are doing, and one number is having 3 decimal place, other number is having 2 decimal place. Your answer should be up to 2 decimal place. One number is having 5 decimal place, one number is having 1 decimal place. Your answer should be up to 1 decimal place. Least number of decimal place you have to consider. Previously they have asked, if they have to ask any single question, means any question from the significant figure, they are going to ask from these two rules. And they may be asking the same example also, not changing the data also. In the previously, whenever you will you will check your PYQ, you will realize that they are asking actually from the significant figure these things. Because finding the significant is very easy part. So we can see here one example is there. For example, sum of the number 46.32. Again, they are not going to check your plus or minus skills. They want to check whether you know this rule or you don't know. So, for example, this one, and this one, okay? We have to add, these are 3, okay? This plus this plus this, okay? You have to add. You can add normally, there is no problem, okay? Normally when we add this one, we are getting 663.821, okay? We can easily add 663.821. But this is not the answer here. Answer we have to give, in this one, 2 decimal places are there, okay? Here, 2 decimal place. In this one, 1 decimal place. And here we can say 3 decimal place. Your answer should be in the 3 decimal place, in the 2 decimal place, or in the 1 decimal place. I'm asking those who are present in this side, because YouTube, I think you are not able to respond, but here these people are able to respond. Say fast. You will answer this question. This is your direct plus. Direct plus anyone can do, 663.821. But is this correct answer? Will not take this one answer as the correct. We have to take here, in this one 2 are there, here 1 is there, here 3. My answer should be only 1 decimal place, and 1 decimal place means your answer goes here, your 663.8. We will round off, because you have to round off this 2 1 is okay, less than 50, so we can say this becomes 663.8. okay, clear? I hope everyone got 663.8. I will take some more examples, means these examples either from the NCERT exercise, either from the exemplar. These rules just how I explained. I hope rules are clear. So whenever multiplication and division is there, you will consider the least number of significant figure, and whenever plus and minus is there, you need to consider the least number of decimal place. Wherever least decimal places, like here in this one 2 decimal, 1 decimal, and here 3 decimal, we have to give answer as the 1 decimal place. That's why answer for this one becomes 663.8. okay, moving further, we got this question. See here, each side of the cube is measured to be 7.2g3. First example from the NCERT coming. Previously were the in text example. What generally happens, we do only solved example. In text example we are not doing. So in this one we have taken all, whatever the in text is there, either solved is there, either exercise important question, either exemplar. Each side is given here. So side we got in this one, there is a 7.2g. They're asking what is the surface area. And surface area, you know that we have to write as 6a square. So 6 and a is 7.203 whole square. Okay. Now this is the surface area. We can multiply, and then volume we can say this becomes the a cube, and a cube means we can write here your 7.203 whole cube. Mostly you don't have to multiply. Okay. You don't have to multiply, because you will see the options are ready, and when options are ready, then directly we can answer. Now what people do the mistake here in this one, this is having how many significant figure? Because we are having the multiplication, so you can say this is the 4 significant figure. Sometimes people take for this constant also. This is the constant. For the constant, no need to take any significant figure. Constant can have as many as significant figure. It can have 1 also, it can have 2 also, it can have 3 also, it can have 4. So your answer will be decided by the 6, or answer should be decided by the 7.203. What do you say? Your answer will be decided by the 6. Will you consider significant figure in the 6? Or answer should be decided by the 7.203. Lot of people are having this confusion. NCERT clearly writing here in this pen, the number of significant figure in the measured length is 4. Whatever the measured value, okay, what are the measurement we have done, how many significant figure, that only you will consider for the calculation, not in the formula like 6 a square coming, or here we have a cube coming, or sometimes cube we are writing 4 by 3 pi r, 4 by 3 pi r cube. So 4 by 3 pi r cube will decide by the r measured value, not by the constant value. So they are writing the calculated area and the volume should therefore be rounded off to 4 significant figure. Okay, means answer of this also should be up to 4 significant figure. Here also 4 significant figure. When we'll multiply, okay, or without multiplication, you can just check the answers in which 4 significant figure. So we got here your area as 311. Here 4 significant figure. Here also 4 significant figure. I hope we can do this one. Then these type of questions can we do? Say fast. We need to go with the speed of almost per one slide per minute. 1 slide per minute, we can easily finish. All the things will be done. Okay. So this question done here. Then we got this next question. 5.74 gram of substance occupies this much volume. So you can say, sir, density we have to find. Same previous question. No? This one is having here 3 significant figure, because everyone knows density is nothing but the mass by volume. Density is the mass by volume. And if density is the mass by volume, then we can say here in this one mass is 5.74 divided by 1.2. Here 3 significant figure, here 2 significant figure. You know your answer should be having how many significant figure? In density you will have 2 significant figure or 3? You can say only 2 significant figure. We take the least number of significant figure. So we can say when you will divide this one, okay, it comes here 4.8, and this is having 2 significant figure. Okay. And how options will appear? Options will appear like this. In option they will say, option will be like this, 4.76. Number B, option will be the 4.763. Option C, 4.8. Option D, they are given 5. Which one we are going to take? Answer is 4.8. Most division is there, na? So when division, then okay, we can divide, but most of the time you don't need to multiply or divide. You will check the options. You know, this one 3 significant figure not possible, 4 significant figure not possible. So this is the answer possible, 2 significant figure. Like this, they will make the options. Okay, I will tell you objective question also for the okay, for this purpose. I have kept some objective questions from the exemplar, so that we can check how options will be there in the final examination. Okay. Now, moving further for the next one. This is the one, okay, again point that we do the mistake. A dimensionally correct equation need not to be actually an exact or correct equation. Means dimensionally correct, okay. A dimensionally correct equation need not to be an exact equation. Like if I say T equal to, okay, root L by G, okay, T equal to root L by G. Is correct or incorrect equation? T equal to root L by G, if I say. What do you say about this one? T equal to root L by G, H. This one we can say dimensionally correct, okay, dimensionally correct, but it is correct or but it not exact, okay, not exact or correct. Okay, it is dimensionally correct but not exact. So they are saying a dimensionally correct equation need not to be actually an exact equation, but it dimensionally wrong. If suppose any formula is dimensionally wrong, if dimensionally wrong means 100% wrong. Equal to 2 pi root L by G. This thing was missing. No? So we can say if dimensionally correct, maybe dimensionally correct may or may not be correct. No? May or may not be correct. Dimensionally correct may or may not be correct. But dimensionally incorrect. Dimensionally incorrect is dimensionally incorrect. If I say dimensionally incorrect, statement will be asked. Because dimensionally incorrect is always going to be what? Incorrect. That is written. Dimensionally wrong formula, dimensionally incorrect or inconsistent equation must be wrong. Okay. So dimensionally correct can be correct or may not be correct. Because constant might be missing because we cannot find the constant. But if dimensionally wrong means 100% wrong. No doubt at all. Okay, 100% wrong. Clear this statement here? I hope all got the okay. Dimensionally correct formula may or may not be correct. Sometimes it can be correct if constant not there. If there is some constant involved, using the dimensional method, we cannot find that constant. So sometimes correct, sometimes not correct. But dimensionally incorrect, if anything is dimensionally wrong, then 100% that formula is wrong. Okay, clear? We got here some examples. Okay, this is the examples from NCERT, so I will be taking. See this side. They are writing SI unit of energy is this, that of the speed is this. Okay, acceleration they have given. Then which of the following, okay, formula for kinetic energy given below can you rule out? You can cancel, that not possible. You can say first one, m square v cube, possible or not possible? First of all, say about this one, possible or not possible? First one, you can say, sir, first not possible. Second, possible. Third one, m into a will be the force, not possible. This one, possible. E, this also not possible because ME, this MA will not match. So dimensionally, I can say B and D correct. Okay, dimensionally B and D correct. Okay, but if I have to ask which one is actually correct answer, out of the B and D, which one is actually correct? They have given these four options. They are asking dimensionally correct. Which one are the dimensionally correct? B and D are the dimensionally correct. But which one is the correct formula? We can see dimensionally both options are correct, but correct formula if I want to choose, okay, then we can say correct formula here becomes actually B. Clear? For the kinetic energy. Okay, so B and D are the dimensionally correct. Correct formula is here D. Okay, so you will check what they are asking. We got this one. So it is written also. Note that dimensional arguments cannot tell which of the following B or D is the correct formula. Dimensionally arguments cannot say that 100% correct. It can only say dimensionally correct. For this, one must turn to the actual definition of kinetic energy. The correct formula for the kinetic energy is what? Given by B. Okay, correct formula is given by B. Over? Good. Now we have here in this one, which of the following pair have same dimension? See this one first of all, which have same dimension. Okay, everyone knows that here in this one, force and momentum don't have, pressure and energy don't have, energy and power don't have. So which one is there? Work and torque. Okay, work and torque have the same dimension. Okay, but if we ask one question here, a lot of people do the mistakes I have previously asked. Can I add work and torque? Summation of work and torque, possible or not possible? Summation of work and torque, possible or not possible? What do you say? Say fast. We cannot add. Okay, what reason you will give? One is the scalar, other is the vector. So summation not possible. Okay, being the one vector quantity, one scalar quantity. Okay, but torque and work have the same. Okay, like these they can ask your options. Like questions are there. These questions are from the exemplar like this. The exemplar 2.4. They are saying number. Some are not properly because I have taken from the different resources. Okay, so sometimes not properly. Okay, this is the NCERT exemplar. Okay, and 11th 2.745 and 2.7. I think it is visible now. Visible to everyone. 2.745 and 2.735, rounding off to three significant figure. Okay, you can say three significant figure if I have to round off 2.745. You know that if digit to be rounded off is 5, है digit to be rounded off 5, then you will check the previous one. If previous even, then no change. Previous even, then no change. So this one becomes 2.74 only. If even, then no change. Rule is saying this thing that if digit to be rounded off is 5 and previous digit is your even, then there is no change. But if it is odd, then it will increase by 1. So we can say here 2.735. Here I have to round off this 5, so you can say previous digit is 3 here, that is the odd, so this becomes 2.74. So rounding off both becomes basically your 2.74, 2.74. Okay, clear? I have just taken only two options, correct options, not all the options not came. Okay, so 2.74, 2.74. Okay. Next question is there that length and width of rectangular sheet, length given L and B both are given. Here you can say this is the L, okay, L given which is the 16.2, your B given which is the 10.1, and they are asking that you have to answer. So we can say you have to answer basically area. So area is basically your L into B. Here you can say this one three significant figure. Here in this one, three significant figure. Okay, so your answer must be having how many significant figure? Are you going to multiply here? Will you multiply? No need of multiplication. Like some people were asking here, sir, how to multiply? Mostly multiplication not needed at all. Okay, no need of multiplication. We are not going to have any multiplication. So we can say options I will see, because I know roughly this is around 162, around 162. But three significant figures should be there. In this option, three significant figure. You can say plus minus some error, nothing, okay? You don't have to, okay, confuse yourself. In this one, here three significant figure. In this option, five significant figure. In this one, four significant figure. In this one, five significant figure. Which option you will choose now? Obviously, you will choose which one? Three significant figure you will choose. A very important question, because directly exemplar questions they ask. Last year people were asking that paper here, there. They actually asked questions from the exemplar. I cannot say all the questions, but a lot of questions were there from there. Over. I will tell you also there's some chapters. Clear? So multiplication may not be needed all the time. You can just check the significant figure. Here, this is having three significant figure. This is having three significant figure. That's why my answer should be having three significant figure, which is only in the option, okay, option A. Suppose in this one they are saying one is having two significant figure, then my answer will go for two significant figure in that case. Okay. Comes okay, here this question, very important question. PQR are the physical quantities having different dimension. And we can add directly, direct plus minus only possible between quantities of same dimension. Plus and minus only possible between quantities of same dimension. Plus and minus only possible between the quantities of same dimension. Okay. So plus minus, okay, possible between same dimension. Okay, so they are saying PQ are the physical quantity having different dimension. So direct plus minus not possible. So first one direct okay, P and Q subtracted, possible or not possible? Possible. It cannot be giving the meaningful. P and Q are, in this one we can say that here this one possible or not possible? Possible. Okay, this one we can say possible. Okay, why this is possible? We can say that in this one because PQ can be same as R. When you will multiply the PQ, then the result of PQ can be same as R. Okay, direct plus minus not possible. You have to check that wherever direct plus minus happening between these individual quantity, that one not possible. So you can say direct plus minus is happening here and it is happening here. So A and E not possible because their direct plus minus is there. Between the different quantities, direct plus and minus not possible. है ना? Because question is asking can never be meaningful. Which can never be meaningful? In which direct plus or minus is there, that can never be meaningful. Wherever direct plus or minus is there, that can never be meaningful. Okay, direct plus or minus is there. Direct plus minus, okay, first multiplied, then plus minus, okay, happened first, then the square, then multiplication, then anything is possible, but direct plus minus not possible. This thing you have to keep in the mind. Clear? Direct plus minus not possible. Anyone? Okay, so this is the key point. Direct plus minus not possible. Okay, anywhere if they are doing the direct plus minus, that option you will discard. Okay, that not possible. Okay, direct plus minus between the independent quantity we cannot do. Photon is a quantum of radiation of energy with E equal to h nu. Again, exemplar question. And here they are asking that E equal to h nu, where h is the Planck constant. Dimension of the h are same h. Okay, I hope you can check. H dimension you have to find. So h dimension will be the E divided by here what? Nu E is basically mL2 energy minus 2 divided by frequency will be the T minus 1. So this becomes here mL2 T minus 1. Okay, and then you will check for this one. You will check for this one. You will see it is matching with the angular momentum, and it will be a mixed angular impulse as well as your angular momentum. Okay, angular momentum, I can say angular momentum is basically what? MVR. M we can say MV is the LT minus 1, it is the L, so you got the answer here, ML2 T minus 1. Very important question you have to keep in the mind. Okay, clear? This one also we have to check. Okay, so they can ask questions like this, one quantity given, and they can say which of the following can have same. So we got okay, moving further. Oh, this is the copied one more time. Oh, in this one basically checked here. Okay, dimension of linear impulse checked, dimension of angular impulse checked. Okay, if you don't know what is the formula of angular impulse, then this is the I omega, like this checked here. Okay, same question. Then it comes from the instrument. Instrument always important. Whatever questions mostly they are asking is not very tough. If it is too tough, we have okay, in the notes already discussed. But basic questions we cannot. Like this is the one simple question given here. Vernier scale of traveling microscope. They have mixed with the traveling microscope. Traveling microscope is the one list of experiment. After the class, please share this notes. Okay, I will share these notes. Okay, these notes you will get. Okay, I will ask them. Okay, I will ask them to upload. Okay. Vernier scale of traveling microscope. Traveling microscope is the one experiment here, because you need to revise also 2-3 times. You will just quickly you can see 50 divisions which coincide with the 49 main scale division. Okay, main scale division is 0.55. Calculate the your minimum inaccuracy in the measurement of distance. Minimum accuracy is basically your least count. So least count we have to figure out. Okay, what we have to figure out here? Least count. Okay, so we can say how to figure out least count here. Least count formula is very simple. I can see it is given by least count is simply, I can write here, it is the MSD minus VSD. So now we can see here in this one they have given that 50, okay, 50 VSD coincide with the 49 MSD. Okay, given here 50, okay, vernier division coincide with the 49 main scale division. Okay, vernier scale of the traveling microscope has 50 division, means this is the vernier division. So 50 vernier division are actually coinciding what? 49 MSD. So we can say 1 VSD. So we can say 1 VSD will be actually your 49 MSD divided by 50. We can put here your least count equal to MSD minus here 49 by 50 of MSD. Then you can say this becomes finally MSD by 50. MSD is given here. What are the MSD main scale division? 0.5. So 0.5 divided by 50. Then the 1 by 100, so 0.01. Okay, mm. Least count is the maximum possible error. Okay, always remember, least count is the maximum possible error. Anywhere they are asking that what can be the maximum possible error, what is the maximum, so we can say that okay, it will be represented by the least count. Okay, they are asking calculate the minimum inaccuracy. Okay, so minimum inaccuracy will be this much, inaccuracy will be 100% there, because lesser than this, what is the meaning of least count? Lesser than this you cannot count. This is the minimum count, this is the least count you can count. Okay, so this is the least, okay, this is the minimum, okay, inaccuracy, this much inaccuracy will remain there. Okay, this much error will be always there. These are the some things that you do all the time mistakes. Kilometer per hour coming, if you have to convert into the your meter per second, like in the kinematics you will do, you can directly multiply with the 5 by 18. Example is 90 kilometer per hour. So 90 into 5 by 18, which becomes 25 meter per second here. Nanometer and angstrom. This conversion also you keep on doing the mistakes. We use mostly in the Bohr model, your photoelectric effect, dual nature we use. So nanometer means 10 angstrom. Because here we are having the measurement also. So that's why these are the very popular measurement where you do the mistakes. cc. 1 cc is basically 10 power minus 6 meter cube. We will use in the KTG part. 1 liter 10 power minus 3 meter cube. Okay, so these are the some okay basics measurement here in which you cannot do the mistake. This is the again your question from exemplar. I think NCRT questions, not exemplar. A unit of length is chosen such that the speed of light in vacuum is unity. They are asking speed of light, that is a c basically. C is taken as 1 unit. Okay, C is taken as 1 unit. Okay, so speed of light is unity. What is the distance between sun and earth in terms of new unit? If light takes 8 minutes 20 seconds, so time is basically 8 minutes 20 seconds. This one you can say in the second format, it becomes basically 480 plus 20, which is the 500 second. Distance we have to find. Distance is always given by velocity into time. Okay, now c into t. But what is the c actually? C is just 1 unit. C is 1 unit, so you can say t 500 into 1 unit. Okay, so this becomes basically 500 unit. So distance in terms, if speed of light is taken as single unit, as per the question they are saying a new unit is, okay, unit of length is chosen such that speed of light in vacuum is how much? Unity. Then what is the distance between the sun and earth in terms of the unit? Answer is what? 500 units. Okay, clear? C we have just kept here 1 unit. Comes some more questions from the exemplar. If momentum, area and time are taken to be fundamental quantities, okay, whenever they ask questions like this, they are saying momentum and this are taken to be fundamental, then energy has the dimension formula. Here you can always check by the option. First is the option checking method. Okay, option checking will work. Second method is you can okay, do some plus minus and then figure out the things. Third is the actual method. We write like this, that here in this one, like E proportional to P power A power A, we can write like this. P, okay, energy has the dimensional formula, so we can say energy proportional to P power X, A power Y, and then we can write T power Z. Then both sides we have to write the dimension. E is the ml2 T minus 2. Here we carry some constant will be there. So okay, I'm going to ignore here. P is the momentum here, so which becomes mlt minus 1 power x. A is the area, L square power y. This is the T power z. And then x, y and z value you have to figure out. Can you find it? I think here better. M power 1, L power 2, T power minus 2. This side I will write M power actually X. M power X. L power, if I say that this is the X plus 2Y and t power, if I say, then this is the minus x plus z. X value you can find. X is actually here and here, so x is 1. So x I can say becomes 1. X is 1. Okay. X is 1. There are the actually three options. I have to solve for the next also. So we can say x plus 2y is 2. X plus 2y is 2. X is 1. So we can say 1 plus 2y equal to 2. So this will be the 1. So 2y equal to 1. So we can say y equal to becomes 1 by 2. Y equal to 1 by 2. Okay. Y equal to 1 by 2. So we can say y equal to 1 by 2 is only in this option. That's why this one becomes correct one. No need to solve further. Right? Over? Clear? Okay. Like this we can solve. Okay. This is the one method, important method you need to know. Then we have here some questions like this from the homogeneity. If velocity is given v equal to at plus bt plus ct square, then they are asking what the dimension of c. Okay, so we can say if this is the velocity, then this should be velocity, this should be velocity, this should be velocity. Means a should be basically velocity, means which is the lt minus 1. bt also should be the velocity, which is the lt minus 1, means b I can write here actually lt minus 2, and your c, which is the ct square, should be also the v, which is lt minus 1. So we can say this becomes here c equal to actually your lt minus 3. Okay, from the principle of homogeneity, means if this side is the velocity, that side also must be the velocity. Can we solve the questions like this? Okay, we need to go a little bit fast because we are completing almost reaching the 45 minutes done. 45 minutes means this should be over because this is a very big chapter actually, and its weightage also more. Most important pattern, last year I said the same question. Similar pattern was asked in the examination also. This is a question from the exemplar only. Same question was there. So whenever power based question is there, like z equal to a square, z equal to, they have given here a square b by c cube, then you can always say like this, delta z by z into 100 equal to, we can say 3 delta a by a into 100 plus we can say delta b by b into 100 and plus we can say 3 delta c by c into 100. Even though powers are negative, if you take this one upside, it will be negative, but you have to keep always positive. Errors are going to be added all the time. Okay, errors are added, so we can just keep the values here. 3 in a, they have given how much error is there. There is the 1%, so 3 into 1 plus in the b there is the 2 and in the c 3, so 3 into 3. So now we can say this becomes 3 plus 2 5. Correct na? 3 to 5. 1 minute, let me see. If the percentage error in A, B and C are, okay, 1%, 2% and 3% respectively, then we have to find, oh, this one is wrong written. It is the 2 here. This is the 2. That's right. So 2, so we can say 2 and 2, 4. So this becomes 4 plus 9. Answer is 13%. Okay, here power is 2. Only 2 will be coming outside. Clear? Power of A is 2. Over. Can we do power based questions? Everyone can do power based questions? Clear. Okay. One more question. Okay. Comes here. Professor Cool claims he can measure the thickness of human air. Okay. Human air using a screw gauge with the least count of 0.01. If you take the least count of screw gauge is this much, okay, screw gauge, then we can measure this thickness of the human air also. So they are asking if the measurement is 0.49 mm. This is the exemplar question only, just how change slightly language. So we can say main scale reading is actually here 0.49 mm. And circular scale reading is basically 3. Least count is given here 0.01. Reading formula is all the time, okay, you know, this is the main scale reading plus least count into CSR. Main scale is 0.49, least count is 0.01 into 3. So this becomes 0.49 plus 0.01 3, which is the final answer. Yes? Clear? Can we solve questions like this? Okay. So answer becomes here 0.052. Your in the error part is done. Okay, we were expecting in the 45-minute we'll finish. 45 minutes almost it is closed. Okay, if you want to ask something in here, you can say fast. I will be now moving for the gravitation. That is the next topic. Almost whatever the important questions were there in the either in text, including your how to calculate the error, how to get the significant figure, how to do the questions on the dimensions. 3 parts are there. We have covered that one. Coming for the gravitation. Gravitation we are expecting to finish in the next 25 minutes. First one. This is I have taken from the summary. Means, okay. Kepler's law of planetary motion state that, because from the summary or sometimes they make the questions. So first one is known as all planets move in the elliptical orbit with the sun at one of the focal points. This is known as law of orbit. It is the first law of orbit. Elliptical orbit is there. Second, radius vector drawn from the sun to a planet sweeps out equal area in equal time. This follows from the fact that force of gravitation on the planet is the central, and hence angular momentum is conserved. Okay, so second is known as law of area. Okay, second is known as your law of area. Okay, and what law of area is saying basically that dA by dt is constant. Okay, dA by dt is L by 2m. And this is constant. Okay, m is already constant, so we can say angular momentum is constant. Okay, angular momentum is conserved. Okay, angular momentum conserved about sun. This thing you remember, angular momentum conserved about sun. And what second law is saying? Second law is saying that angular momentum conserved. This is that, okay. So second law comes from the angular momentum conservation. Then third is the square of the orbital period of the planet is proportional to the cube of semi-major axis of the elliptical orbit. Means t square is proportional to r cube or a cube. Okay, whatever we say. Okay, a cube. This is the actually there. Okay, t square proportional to a cube. Okay, or we can write like this also, that t square equal to 4 pi square by gms. This is the constant t square equal to Ka cube. K is the constant. Okay, in this K constant is the 4 pi square by gms. Remember 4 constant, pi constant, g constant. Ms is the mass of central body. In this case, central body is what? Sun. Okay, where m is the mass of the sun. But remember, this formula is valid for the satellite also. So m will be representing here central body. Okay, most planets have nearly circular orbits about the sun. For elliptical orbit, the above equation is valid if r is replaced by the semi-major axis A. So this one is for the elliptical orbit. They are written for the almost circular, because most of the planets have the circular orbit. Okay, that's why A is replaced by the r. Okay, A is replaced by r. Why A is replaced by the r? Because most of the planet have the circular orbit. But if this is the elliptical orbit, we can take the semi-major axis A here. Okay, but K is same for all planet, or K is different for all the planet? See first. K is same for all planet or different for all planets? They will ask this question. Then in the Kepler's third law, K is same for all the planets or different for all the planets? I'm asking to you. You need to respond fast, because by 10 we will finish also these things. This K is going to be same for all. Okay, because here we can say this is the ms. It is the mass of central body, sun. Okay, this mass is going to be same. So for our planet, our solar system, we can say whatever planets are there, okay, for all the planet, this K is going to be same. Clear? Okay. Here graph also comes, that they will ask. Okay, first question already I said that this constant K is same for all. okay, all the planets. It does not depend on the mass of the planet. Some people think here this is the mass of planet, this is the mass of central body, like mass of central body means mass of sun here. They will ask what is the graph between t square and okay, r cube. So t square and r cube graph we can see straight line, because we know t square is proportional to r cube. So this graph is going to be a straight line here. Okay. Now, this is the one more thing. Law of area can be understood as a consequence of angular conservation of angular momentum. Okay, this thing. Law of area can be understood as a consequence of conservation of angular momentum, which is valid for any central force. Okay, so conservation of angular momentum is valid for any central force. Any central force. Na? Whatever the central conservation of angular momentum can be valid. A central force is such that, what are the central forces such that the force on the planet is along the vector joining sun and planet. Okay? So force is along the line joining, then we can say this is the central force in short. Let the sun be at origin and the position and momentum of the planet be denoted by r and p, then the area, okay, they have just calculated here, okay, they got this dA by dt, how much? L by 2m, okay, L by 2m, okay, and okay, L is constant. What you have to remember here in this one, that
pen color will change.
pen color?
Pen color change. We are able to see. So it's right.
Yellow not coming.
Not
Which one?
any.
First of all, you need to remember here what is the your okay, law of area can be understood as a consequence of conservation of angular momentum. Ana? And angular momentum is valid for any central force. I will take one okay, question on this one where a lot of people can do the mistakes. Means your any central force is there, conservation of angular momentum can be there, okay, and from there only we are getting the dA by dt. So you have to remember that dA by dt is all the time equal to here L by 2m, which is basically mvr divided by 2m, is this becomes actually vr equal to constant. It means v proportional to 1 by r, as r will be closer. So this is the one question they ask that here this is the sun, okay, and they will be asking here, this is the your planet actually, that here speeds, because this is the r is minimum, here speed is going to be maximum, and here we can say r is maximum, speed is going to be minimum. Okay, clear? Done? And this part. Okay, so they will ask okay about the kinetic energy also. So we can say like they will say the one okay, some questions here, like they can say this is the K1, this is the K2, this is the K3, and they're asking where kinetic energy is more. Then we can see here this is the your K1 is maximum, after that K2, after that you will write the K3. Okay, after that K3 will be coming. And this one I'm going to take one question will be coming, okay, on this. So you will remember here. In the next only coming. First of all, this question comes here. Let the speed of the planet and the perihelion, okay, VP and okay, this RP, relate the RP to the VP. Okay, so we already know that okay, M1, okay, MP RP VP equal to MP RA VA. Mass will be cancelled, so VP by VA equal to RA by RP. This is the first part, already we know. Right? Second, they are asking here in this one, will the planet take equal times to traverse BAC, means from here BAC, okay, here to here, okay, here to here, and okay, next time it is going from here to there, okay. So this one, okay, your violet and this pink, both the time are going to be same or different. They are asking this thing. both the time, because both the length are same. This is the half part, this is the half part, but both the time not same, because this side area is always area velocity constant, not the linear velocity. So we can say area will take with respect to sun is here. So we can say this side, okay, your violet side here area, if I cover, then this is the area this side, and this side area is certainly 100% more. And if here area more, okay, we can say area more, so time also more, okay, so t more, okay, so time will be more for this part, okay. Here it is covering more area, that's why more time is taken. Can you remember this thing? Here less area means less time is there, okay. More area, more time. Here less area, less time, okay. So two questions are there. One is related to the speed, other is related to the time, okay. Then comes here your three equal masses of m kg each are fixed at the vertices of equilateral triangle, okay. So I can draw here three equal masses like this. I can say here, so three equal masses are there, okay, at the vertices of equilateral, okay. Here m, here m, here also m, and they're asking what are the force acting on a mass 2m placed at the centroid. At the centroid, if I keep 2m, if I keep 3m, if I keep any m, then total force is going to be what? 0. Why total force is 0? Because this will attract this side, this will attract this side, this will attract this side. So all summation becomes what? Overall, it becomes 0. Okay, so we can say F net will be 0 in this case, because all will be attracted here. So net force will be 0 at the center if all masses are same. If all three masses are same. Now what they are doing here in the next question, what are the force if the mass at the vertex A doubled, means this is the vertex A, B, C, A, how given the name, at A doubled. So we got the diagram here like this, that in this one, this becomes the 2m, this is the m, this is the m, and here this is the 2m only, okay. Now we can say this 2m I can read as m plus m, 2m we can read as m plus m, 2m we can read as m plus m. Earlier here m was there, but okay, now it is a 2m, so 2m I'm reading as m plus m. So you see, because of this m, this m, this m, total force will be what? 0. They will be cancelled. So what is only left? This m is left, and force will be 100% the vertical direction. And this force we can say directly g into 2m square divided by this distance. This distance you can calculate r square. Clear? If m will be cancelled, but if this is the 2m, you can think like m plus m. So m done, only one m left, and this force will be vertically upward here. Is clear? Both parts are clear to everyone? Okay, so now moving for the next example. Okay. This is the NCERT exercise question, very important. Last year also they asked. Last year similar question was there, if you remember. Body weight 63 Newton on surface of Earth. What the gravitational force on it is due to Earth at height equal to half of the radius of Earth. So we can say this is the actually formula with the depth GD is actually equal to G 1 minus D by R. Okay, this will be only useful whenever you will revise one time and you will do your face, because I have kept a lot of questions in the face examination also. We tried to cover almost whole exemplar and these important questions of the exemplar, whatever not possible in this one, we have covered there. So GD equal to G 1 minus D by R. So we can say they are asking about the weight. So I can write M here, here also M. MGD we have to find. So MG is basically at the surface 63. Then we can say 1 minus D. Okay. D is half the radius. So we can say R by 2 into R 1 by 2. So we can say this becomes 63 1 by 2. Okay. Clear? What is the gravitational force on it? Gravitational force on it means they are talking about the weight only at a height. Oh, height is given. Oh, not this, the depth. Okay, this is the for depth. Okay, here given height. I thought this is the depth given. This year question for the depth was asked. Here height is given. So for the height, we'll use this formula GH equal to G divided by 1 plus H by R whole square. So I can say here M. One question for the depth also will be there. So we can say 63 divided by, okay, 1 plus H R by 2 into R whole square are cancelled. So this becomes 63 divided by 1 plus 1 by 2, 3 by 2. 3 by 2 whole square will be 9 by 4. This is the answer, okay. It is due to the height and due to the depth that previously I had done, okay. So height and depth both can we remember? Okay. So maybe with the, okay, this is with the depth given. Hai? How much would a body weigh down to the center of Earth? Okay, halfway down. Okay, this is the question with the depth. Halfway down to the center of Earth if weighted 250 Newton on the surface. These type of questions they ask multiple times. So 250 on the surface. Then what is the at halfway? So we can use this formula which is the just already previously G 1 minus D by R, and then we can say this is the M here M. Mg value is 250, and here I write 1 minus D is R by 2 into R cancelled here. This becomes 250, 1 minus 1 by 2 over. With the height and with the depth, can we do the questions? It is always important and it is very basic, very simple, okay? Now comes this question. I personally like this question. They can ask anytime. Till now, they have not asked it. The exemplar question, I expected last year they will ask, but last year they were in the mood to ask very simple question from the gravitation. This appears like tough question, but actually very simple. They are saying a particle of mass 2m, m, and m respectively at the point A, B, C are kept here. AB is half of BC. BC is double actually. If I take this one is x, this one is 2x. M is much smaller than m, okay, and t equal to 0. They are all at the rest at subsequent times before any collision. So we can say that okay, we have to talk about the m. So this will try to attract here. What are the force? Okay, force of A basically we can say. So we can say this side force, okay, will be your G into 2m by x square. And this side C will apply. So what is the force of C actually here we can say G into m divided by 4x square. Which force is more, A or C? Which force is more? Force of A is more or force of C is more? Which one is more? Because we have to talk about the M, not about capital M, only about the M. You can clearly say, sir, force of A is more. And if force of A is more, then it will be moving towards which one? It will move towards, say fast, those who are present here. Okay, in this case, force of A is more, so we'll be moving towards the A, moving towards A. Okay, so we can say in this case, M will move towards A. A is basically your 2m. M will move towards 2m. Okay, so very simple question. Appears like they will say that oscillatory motion, okay, then okay, will remain at the rest. Then we have to think, but nothing. Just force you have to take. Force this side, force that side. Okay. Comes here this one. Find the potential energy of a system of 4 particles placed at the vertices of a square of side L. Okay. Now in this one we can say whenever we are finding the potential energy of this, okay, here M, here M, here M. So in this case, how many interactions are there? So 4 interactions are along the side. Potential energy is all about the interactions. And 2 interactions are the diagonal interactions. So we can say potential energy, if you have to write, it becomes basically minus 4 gm square divided by here A or L they have given. So we can write L. There are the 2 interactions, these 2, which are the along the diagonals. We can say gm square divide by, we can say this becomes here root 2L, because distance for these diagonal will be the root 2L. Okay, then we can do the calculation. Okay, clear? Calculation is just you have to put the value of root 2, nothing. That is the final answer. Comes here escape velocity. Okay, escape velocity, more questions are not there, so I have taken some question. Escape velocity is simply formula, if I say so, formula of escape velocity is here v equal to, okay, root of 2gm by r, or I can say root of 2gr, or in terms of density I can say 2g by r. Mass will be the volume into density, so you can write here 4 by 3 pi r cube into rho, and you can simplify. So escape velocity is independent of, okay, you know, it will depend on the mass of planet, it will depend on the radius of planet, it will depend on the gravitational constant, so mass of the object. It does not depend on the mass of object. Okay, it does not depend on mass of object. Okay, so if I project this pen, either I project from very heavy body, either I project the rocket from the surface of Earth, then from the surface of Earth, escape velocity for any small object or heavier object remain 11.2 kilometer per second. Okay. Second question is, the radius of Earth suddenly becomes 4 times larger and mass remains same. The new escape velocity will be. So we can say earlier velocity, suppose root of 2gm by r, new velocity v dash, we can write here root of 2g, mass remains same, and radius becomes 4 times larger, means here 4r. So this will be coming outside, so 1 by 2 of this 2gm by r, and you know this is the ve, so this v dash becomes basically v by 2, means becomes half. Okay, this is given here. Okay, an object is projected with the escape velocity from Earth, ignoring the resistance, total mechanical energy at distance from the Earth is. Here I will say, remember 3 things. Velocity of the projection, I'm saying here in this one, velocity of projection is equal to velocity of escape. Velocity of projection is greater than v escape. Third thing you have to remember, velocity of projection is less than velocity of escape. 3 cases are there, very important cases I'm writing here. So we can say when velocity of projection equal to velocity of escape, in this case, okay, just reaches infinity, just okay, reach infinity, and then we can say total energy becomes 0. Okay, total energy will be 0. In this case, we can say when Vp is more than V, okay, reaches infinity with some k. Okay, some kinetic energy will be still left. Okay, some k. So here we can say in this case total energy is more than 0, means positive, and speed at the infinity is given by here in this one, that we can find. Okay, how much speed will be left if you want to find, then we can say velocity at the infinity equal to basically you can say Vp square minus VE square. This is the formula you can remember. Okay, Vp square minus VE square. Okay, velocity at the infinity equal to Vp square minus VE square. And okay, sometimes they will say Vp equal to like Vp equal to KVE, then you can put the KV, so this formula becomes root of K square minus 1 into VE. Okay, but this one also enough. Here we can say will not reach infinity. In this case, will not reach infinity. Okay, so here your total energy is still negative, bounded. Okay, it is bounded. When total energy is negative, system is known to be bounded. Okay, it will not go to the infinity, and okay, will reach some maximum height, will reach maximum height. And what is the maximum height? If I say Vp equal to K times of VE, okay, where K is less than 1, then H max is given by this formula, K square by 1 minus K square into R. Okay, so these are the 3 cases I have written here: equal to infinity, equal to escape. Now it will go to the infinity. It is more than escape and less than escape. More than this, no one can ask anything in the escape. You will not do mistake in the questions of escape if you remember these 3 cases. Okay, clear? But these cases you can write, okay, already you know, okay, because if I have to move, okay, I have to erase this thing, okay. So this will be erased. This will not be saved in this PDF. Next question comes here. The planet of same density as Earth but twice the radius, escape velocity. You can use the density formula, you can get the answer. Simple one. Comes here in this one. That planet Mars has 2 moons. Okay. Mars has 2 moons. Last time question was from here. They just changed little bit data. Same question was there. Same question. Data slightly changed. They give the data somewhat around 89, some 88. Right? So that is given here that planet Mars has 2 moons, Phobos and Deimos. Phobos has period of 7 hours 39 minutes, and this is the orbital radius given. Calculate the mass of Mars. So we have this formula, T square equal to 4 pi square by gm r cube. Into the calculation, just we have to put the value and we can get. Calculation they are not asking. Then they are asking that, okay, second part, assume that Earth and Mars move in the circular orbit around the Sun with the Martian orbit being 1.52 times. They said 4 times because calculation of 1.52 times is slightly tough. So they give the, if they are giving, then they have to provide this value 1.52 power 3 by 2. This value will be okay, must be provided. So we can write here actually T1 by T2 will be equal to R1 by R2 power here 3 by 2. Okay, this one we can say R, and this one we can write here your 1.52 R power 3 by 2. Then we can do this calculation. So your T2 becomes here in this one 1.52 power 3 by 2 into T1. Of calculation is more. This calculation should be given. That's why what they did, they said radius is 4 times. And if radius is 4 times, then we can say T divided by T2 equal to R divided by 4R power 3 by 2. This is the calculation last year given. 3 by 2. Now the calculation is here as 4, this becomes how much here? Your 1 by, okay, you can say 4 as 1 by 2 square will be cancelled. So this becomes how much here? 1 by 8. So T2 becomes basically here 8T. Okay. Done. Can we solve? Okay. So one was from the variation of G, other was from here. Okay. Energy of orbiting satellite. Energy, kinetic energy will remember simply your half mv square. Half mv square means, okay, this thing comes, okay. Now these are the formula, but I will say you can remember formula in the much easier way, that your potential energy is simply minus of, I can say potential energy, okay, here in this one, minus of G mm by R. Your kinetic energy is equal to here G mm by 2R, and total energy, if I say, then total energy becomes here minus of G mm by 2R. R is written here your R plus H. Small r is nothing but the R plus H they have written. Graph, you remember, graph is same as the Bohr model, like this here, and then this one. This is for the K, this one is for the potential, this is for the total. If you increase the R, then we can see your kinetic will decrease, total will increase, potential will increase. Okay, you have to remember these things, this graph and this one. If you go for the higher orbits, then K will be reduced. Okay, from the graph we can see this is the R's. Okay, so if you increase the R, then K coming down, but P and T going up. Now this is the one question here, appears like calculative, but actually it is not calculative. Okay, because they will not ask the calculation version, they will ask the in the terms of variable, they will not ask you to put the values. If 400 kg satellite, and if they are asking the calculative version also, it is not very calculative. If 400 kg satellite in the circular orbit of radius 2r is moving about the Earth, I will draw here, this is the Earth, It is moving in this orbit. This orbit is 2r. Okay. How much energy is required to transfer it to the circular orbit of radius 4r? So from here I will give some energy. So this will go to the orbit of radius 4r. Okay. So you can say from here to here we have to, okay, it have to move. So how much energy is required? You can see this energy will be, okay, here it is having some energy. This energy, I will take the total energy. In this orbit also we are having some total energy. So I will provide some energy. So I can say total energy initially plus I will give some minimum energy. After that becomes the total energy final. So from here we can say this E minima is simply given by total final minus total initial. How to calculate total final? In this orbit, formula is minus of g mm divided by 2r. R is 4r. Here minus minus plus g mm divided by 2, radius is 2r. This one you have to calculate. So I can say this one becomes actually minus g mm by 8r plus g mm by 4r. Here 2, na? So this becomes here g mm by 8r. This is the answer. After that we have to put the value, and here we got this also g mm by 8r. Okay, g mm by 8r. Then they are putting the values we can put. If they will give up all the required values, we can just put here. Okay, very important question, shifting the orbit of satellite. Okay, so if they're asking shifting the orbit of satellite, can we do it? Okay. We are almost 30% done. Which of the following options are correct? Okay, again question from the exemplar. We know with the height and with the depth it will change. Okay, so acceleration due to gravity decreases with increasing altitude. We know, yes, this one is correct one. Okay, with the altitude this will decrease. Right? Formula also we know. Acceleration due to gravity increases with increasing depth. This one is wrong because we know with the depth also decreases, height also decreases. It is maximum at the surface. You go up, decreases. You go down, it will decrease. Maximum at the surface. Okay. Acceleration due to gravity increases with increasing latitude. That is also wrong. Sir. Acceleration due to, okay, this one. Fourth one, I'm saying, then I will go for this. Acceleration due to gravity is independent of mass of Earth. We know this is the formula here, that G is basically equal to Gm by R square. So it depends on the mass. Thus, this one is also wrong. Okay. Now coming to the C. What are the meaning of latitude? Okay. This is related with your rotation of Earth. Okay. Actually, wherever Earth is having the rotation, in the NCERT rotation, they have not given. But in the question, they have given here. So due to the rotation of Earth, actually, we can see this is known as your angle of latitude. So due to the rotation, G dash becomes here G minus R omega square cos square lambda. Because the C option, people do the mistake. So G dash equal to G minus R omega square cos square lambda here. Okay. Now we can say that at equator, then we can say at equator lambda is 0. So we can say this value G dash is basically G minus R omega square. Okay. At pole, if I say, then we can say at pole lambda will be 90. So cos 90 0. So G dash is equal to G. Means at the equator maximum change happening, at the pole changes are nominal, not happening. Okay. At the pole there is no impact at all. Maximum impact happens at the equator. Okay. Now you know that if you are moving from equator to pole, increasing latitude means you are going from equator to pole. Okay. So increasing latitude means what? Increasing latitude means moving from equator to pole. Okay. And if moving from equator to pole, then what about the G? Equator it is the minimum and pole it is the maximum. So G will increase or G will decrease? G will increase. Okay, so acceleration due to gravity increases with increasing latitude. Clear? Any problem? Any problem? Okay, remember this formula also, G dash equal to G minus R omega square cos square lambda, and then moving from equator to pole, then G will increase. Maximum value is at the pole, minimum value at the equator. Now, this is the one question here, that an object of mass m is raised from the surface of Earth to a height equal to radius of Earth. Then what is the gain in the potential energy? This is not the satellite, this is the body. So this body is basically at the, this is the surface of Earth, and this is kept at the surface of Earth, and from here I am going to the height, that is taken from a distance r to 2r. So right now here, and then we are taking to this one, from the surface of Earth only. Earlier it was r, then it becomes at the 2r. Distance is given directly from the center of Earth. So we say potential energy, change in potential energy will be equal to potential energy final minus potential energy initial. Potential energy final, I can say, minus of G mm divided by R. R is actually 2R, because this is the directly distance given. Here we can write plus G mm divided by R. Here 2, I can make the same base. So this becomes here G mm by 2R. This is the answer. And G mm can be written as mgr by 2 also, because gm is nothing but the gr square. So sometimes we can use this thing. Clear? This also. Okay. NCERT exercise question. This one is the NCERT exercise. Points to ponder, very important. You have to remember in considering motion of object under the already I said that wherever some points to ponder are important or taken, where summary important or taken. In considering points motion of an object under the gravitational influence of another object, following quantity are conserved: angular momentum conserved, total mechanical energy conserved, but linear momentum not conserved. Linear momentum not conserved because velocity keep on changing. Velocity keep on changing. So two things are: area velocity constant, but linear velocity not constant. Area velocity constant, but linear velocity not constant. Angular momentum is constant. Total mechanical energy is constant, but linear momentum not conserved. Second point, angular momentum conservation leads to Kepler's second law. However, it is not special to the inverse square law of gravitation. It holds for any central force. Angular momentum conservation holds for any central force. Already I said in the beginning also. This is not only special to the law of inverse square law of gravitation. It holds for any central force. Angular momentum conservation holds for any central force, not only in the case of gravitation. In the Kepler's third law, T square equal to KSR cube, the constant Ks is same for all the planets in circular orbit, remember, Ks is same for all the planets in circular orbit. This applies to satellite orbiting the Earth also, An astronaut experiences weightlessness in a space satellite. This is not because the gravitational force is small at that location in the space. Sometimes they say that why astronaut feels weightlessness, because gravity is less there. That is not the reason. Reason is because it is always it is because both the astronauts and the satellite are in the state of free fall toward the center of Earth. Force is always toward the center of Earth. Because of that, so they are in the state of free fall. So here gravitation is done, mechanical properties of solids. Coming to this one. First is in the elasticity, you have to remember that different types of materials are there. Okay, here this is your graph for elastomer, this one. Okay, this you have to remember. Okay, and okay, these elastomers don't follow Hooke's law. These elastomers are the material which will not follow the Hooke's law. Where this elastomer, pen color, so this one is basically your elastomer. Okay, so you have to remember that. Okay, this also not working. Black. Okay. So okay, this one is basically for the elastomer. Okay, where these elastomer means and does not follow Hooke's law. Okay, does not follow. Okay, Hooke's law. Okay, elastomers will not follow Hooke's law. Okay, and this one is present in the tissue of aorta, in the heart. Okay, so stress strain curve for the elastic issue of, okay, elastic tissue of aorta, the large tube vessel carrying blood from the heart. Okay, and this one will not follow Hooke's law. This thing you have to remember. Okay, will not follow Hooke's law. Clear? Okay, will not follow Hooke's law. Okay, this graph need to be remembered. This is the normal graph. Okay, so in this graph, in the region from A to B. Okay, so first of all, I will say that O to A. O to A stress is directly proportional to strain here. Okay, stress directly proportional to strain. In the O to A, stress directly proportional to strain. Okay. Directly proportional to this. Hooke's law valid. Okay. In the region from A to B, if you say strain are not proportional, okay, body still returns to its original dimension when the load is removed. Okay. So A to B, Hooke's law not valid. Okay. In the AB, okay, I can say Hooke's not valid. Here Hooke's valid. Okay. But returns back. Okay. But returns back. Okay, it will return back. It will return back means it is basically within the elastic limit. Okay, so point B is known as, okay, I can say here, this is known as your yield point or elastic limit. Okay, so point B in the curve is known as yield point, also known as elastic limit. Okay, so B is known as yield point, either your elastic limit, both points are same. Okay, yield point or elastic limit. If you cross this point B, okay, if you keep on increasing the load, okay, then at C it is not going to break. But if you remove the force, there will be the permanent deformation. Okay, so okay, and the corresponding stress is known as your yield strength of the material. If the load is increased further, the stress developed exceeds the yield strength and the strain increases rapidly, even for a small change. Okay. I think I can make it somewhat zoom. Like this. A small change in the stress, the portion of the curve between B and D shows this. Okay. So basically what happens that if you are crossing the B, at the C there the permanent deformation will be there. It will never return to your original state. So up to B it will return. So up to B is the elastic limit. After B, elastic limit is over. Okay. Plastic limit starts. So your elastic is up to B. After the B, there is the plastic region. Up to B, okay, up to B, we can say this is the elastic part. After B, this is the plastic part. Okay, this is the plastic part. Then, if you keep on increasing, then this is the maximum stress you can apply. So point D indicates the maximum stress or maximum More than this you cannot apply. More than this, if you apply, it will break. Okay, so here it is written in this one that okay, the point D on the graph is the ultimate tensile strength of the material. Beyond this point, additional strain is produced even by reducing the weight. Okay, and fracture occurs at the point E. Okay, means in this one basically D. If you have to find the your strength or something, this is the maximum load. More than this, no one can apply here. Okay, maximum is this. If this D to E is small, if this is small, okay, then we can say material is going to be your brittle. And if this one region is large, then material is going to be ductile. Okay, then material is going to be ductile. Okay, so if small, then this is a brittle, and if large, then this is going to be ductile. Okay. So this is the whole thing. So again, one more time I will say, up to A Hooke's law valid. Okay, up to A Hooke's law valid in this graph. Hooke's law valid. A to B Hooke's law not valid, but it can regain. It can regain. That's why known as your yield point or elastic. Elastic limit. B up to B elastic nature is there. Up to A only proportional nature Hooke's law is there. A to B Hooke's law not there, but it will return. At the point C, it will not return. There will be the permanent deformation. D is the maximum stress you can apply. Maximum. More than this, it will break, and finally it will break at the E. If this one is a small, breaks suddenly, it is the brittle. If this one is large, it is the ductile. Okay. And the tissue of iota elastomer graph you need to remember. Comes here this question. Structural steel rod has radius of 10 mm and length of 1 meter. A 100 kilonewton force stretches is along the length. Okay, so this is there, that is okay. And this one, if I draw here like this, okay, and here they are saying length is 1 meter and this was along its length. Okay, so force is given in this one, that is the 100 kilonewton, means 100 into 10 power 3. Area is given, I think, radius given, so we can say radius. Okay, h how much? Radius is 10 mm, so we can say 1 centimeter. Stress they are asking. So we can say stress is simply here force by area, force by pi r square. So 100 into 10 power 3 divided by pi 3.14 into 10 power minus 2. Then we got the answer. Okay, I hope you can calculate. We got the stress. Then they are asking the elongation. For the elongation, you will use always this formula. Elongation is this. FL by AY. All the time remember this. Anywhere you have to find the elongation, use this one, E equal to FL by AY. In the whole elasticity, if any one formula you have to use, is this E equal to FL by AY. Okay. In whole elasticity that we are going to use is the E equal to FL by AY. Clear? Okay, so we can just put the data here and get the answer of this. Now comes this question, very simple and important question. A copper wire and steel wire, both are connected end to end, stitched by load. Net elongation is given. Net elongation given. I will see the concept because data is not given. Data we have to see from the your table given in the NCERT. So I can say in this one, this is the here copper and this is the steel. Okay, this is the Cu, this is the steel. These rods are there. Okay. Total load, what is the load we have applied? We have to find, we can say this is the force F. Total elongation is given here. Okay. So you can say total elongation is given by simply I can say E1 plus E2, which will be basically 0.7 mm 10 power minus 3 meter. Now we'll put the value. E1 will be equal to F L1 divided by A1 Y1. Both diameter same, so area becomes same here. So we can say area will be same. So A into Y1 plus we can say here F L2 divided by A into Y2 equal to we can say 7 into 10 power minus 4 I can write. Now force, you can put all the data. Y you have to take from the Y will be given here, okay? In this one, Y not given, but Y will be given. As they have given the table here, so they are not given, but in the final examination, they will give you. So force you have to figure out. So force by A, you can write like this. L1 by Y1, all the values will be given to you. L2 by Y2 equal to, we can say, at 7 into 10 power minus 4 and get the answer quickly. Okay. Question is important. Calculation may or may not be there. Calculation can be there. So whenever data is there, depending on the data, if they have given data quite easier one, sometimes they can simplify the data. Good for us. We can do the calculation very fast. Okay. Now, moving further for the next one. In this one, they are saying square lead slab of side 50 centimeter and thickness 10 centimeter is subjected to a shearing force of this. Narrow edge is riveted, means narrow one is fixed, okay? Lower part is fixed here, okay? This part is fixed to the floor. How much will the upper edge will be displaced, okay? So first of all, in this diagram, okay, if you see, we need to figure out the area, okay? So this is given actually here. This is the 50. This is the 50. And this is the your 10, okay? So a square lead slab of side 50 centimeter and thickness 10. So we can see that here we are. So we need to find this area first of all. We are applying force on this one. So this area becomes how much? 50 into 10. So which becomes basically or this. So 0.05 upper area, because we have applied force on the upper part. Okay, here we are applying the force. So this area we are finding first of all. So we got this area 0.05. Okay. Then we have this formula actually that if you remember, eta equal to F by A into X by L. Okay. Rigid modulus is given by this formula F by A, X by L. So from here X we have to find. So your X will be equal to FL divided by A eta. Eta is not given here. Eta they will give you in the questions. Force value we can keep here. Whatever the force value is there, okay, length we can keep, and okay, force is in this one 10 power 9 into 10 power 4, length we can say 50 centimeters, so 10 power minus 2 divided by area, just calculated here 5 into 10 power minus 2. Eta will be given to you. We have to just put the data. We can check here what is the eta taken in this one. Okay, so eta, if they have taken this value here 5. I think this one. This is the eta taken. So we can do the calculation. Eta value will be given. Question from bulk modulus. Average depth of Indian Ocean is about this one. Calculate the delta V by V. Very important question. Very simple. Okay. Here bulk modulus given also. So we can say we know the formula actually. Delta P is, or I can say your bulk modulus is simply given by delta P divided by delta V by V with the minus sign. Okay. Minus P, so it will be decreased. So this is the formula delta which bulk modulus equal to delta P divided by delta V by V. We need to figure out this thing. So you can say delta V by V, if you have to find, then this becomes here delta P divided by beta. Delta P is nothing but the rho GH, change in the pressure. Here pressure is P naught, then at the depth P naught plus rho GH, so it will be the rho GH is the change divided by your beta. Now we can say rho GH, rho is 10 power 3, G is 10, H. H is given here, depth is 3000 meters. So we can say 3 into 10 power 3 divided by, we can say bulk modulus. What is the bulk modulus here in this one? 2.2 into 10 power 9. So we can say here 2.2 into 10 power 9. Okay. Can we do the calculation? Calculation you have to do. Okay. Clear? Okay, this is the delta V by V. Suppose they're asking percentage, so we can say into 100, and here also we can into 100. Now we can say that this is the 3, 3, 6, and 3, 9. This will be cancelled. 3 by 2. 3 by 2 is 3 by 2.2, 3 by, this becomes 3 divided by 2.2%. Roughly, you can say around 1.4 something, 1.36 is calculated here. Now, whenever we are making the pillars, then all the time you remember that while making the pillars, bottom is always wide, okay? Always wide we say, okay? What is the reason for this one, okay? Here, maximum height of mountain on the earth is 10 kilometer. Maximum height of mountain on earth is 10 kilometer. Can also be provided by the considering the elastic properties of rocks. A mountain base is not under uniform compression. This provides some, you see mountains are, you have never seen any mountain like this. Okay. Have you seen mountains like this? Mostly mountains you have seen are like this. Their base is wide. Okay. Base will be wide. And they are, okay, you have not seen any single mountain that base is narrow, okay, like this. You have never seen any pillar also that is narrow and then going like this. Whenever we make the pillar, we make always base is going to be wider. Why base is wider? Because base how to support most of the load. Whatever load is there, it need to be supported by your base. Okay. So in this one, they are saying what is the maximum height of mountain? 10 kilometer, more than 10 kilometer, you don't have any mountain. If anyone is saying that what is the maximum height of mountain in this earth, so we can say maximum height of mountain is 10 kilometer. This is the general knowledge question also, as well as, okay, you can remember. Now, we will calculate. So they have given here in this one, material at the bottom experiences this force, okay, in the vertical, and the sides of the mountain are free. Therefore, this is not the case of pressure or bulk compression. There is a shear component approximately by rho gh. Now, elastic limit given. Elastic limit means more than this, it will break. Sometimes you have seen also that when you are making the, okay, like you are collecting something, you either sand or something like this, okay, making, then always base will become bigger only. And sometimes when you keep on increasing, base will burst also. So they are saying elastic limit for the typical rock is 30 into 10 power 7. The elastic limit means breaking strength. So breaking strength is always equal to F max divided by A. Breaking strength is given here 30 into 10 power 7. F max will be the basically mg by A, mg by A I can write here. So we can say mg, m mass will be the V into rho into G divided by A, okay, mg by A. V I can write here A into H into rho G by A. A I can cancel here. So from here H I can write becomes 30 into 10 power 7 divided by I can write rho, okay. Rho is roughly they have taken 3 into 10 power 3. So I can say 3 into 10 power 3. G is 10 here. So now you can see this H becomes basically 10 power 4 meter or 10 kilometer. Approximate calculation. We have done the approximate calculation. Can you remember? Approximately means maximum height of mountain is this, more than this, not possible. Okay? Clear? This question you have to remember. And this is the question on the breaking stress. We will take some more question on the breaking stress in the next. Modulus of rigidity of ideal liquid. Everyone knows modulus of rigidity of ideal liquid is what? 0. Okay? Because you will apply ideal liquid, there is no, okay? They are, okay, no opposition, so you will apply, they will keep on moving. So basically that here in this one we can say eta equal to F divided by A x by L. This x can be infinity, very, very large. So eta becomes basically your 0 for the ideal liquid. Maximum load a wire can withstand without breaking. Very important question. And we do the mistakes also in this one. They say that when wire is there, this can have, okay, some weight without breaking. Now if we reduce the length, then when length is reduced to half of its original length, then how much load it will, it will be the same or different. So see in this one, breaking stress is simply given by here F max divided by A. So maximum force, if I say, is actually equal to breaking stress into area. So F max depends on the area, not on the length. F max depends on the area, not on the length. Means if this is the your wire, this can have some maximum force. So if you cut into two parts also, then also its area remains same. And if area remains same, then your maximum force will remain same. Okay. So remember, breaking stress that depends on the maximum force is the basically breaking stress into area. Breaking stress is the property of material. So this property of material will remain same. We are not changing the material. So it ultimately depends on the area. So in this question, we can say they are saying here a maximum load a wire can withstand without breaking when length is reduced to half. Now length is reduced to anything. This will remain always same. Okay, this will remain same. Clear? This is the explanation written here. Now, read this thing. In the case of wire suspended from ceiling, in case of wire, we can say here, suspended from ceiling, action of weight, suspended at the other end, this F, the force exerted by the ceiling on, force exerted by the ceiling on it, is equal and opposite to the weight, However, the tension at any cross section is just F, not 2F. Means if you're taking here in this one, then tension at any means here F, here also will be what? Here your F, and tension you will take F. So in this case, if you have to consider the your and this is the wire. I can say this is the wire actually. Wire. Wire means its mass, its own mass is not there. So we can see here F, then here also F. So in this case, stress will be simply F by A. Lot of people, what they think that this side F and this side F, total force becomes 2F. So total force is not 2F. This is your F only. Clear? This point, a lot of people keep on doing the mistake. Okay. Like this, I give you. Tell me in this case also, F and F. What are the stress in this case? F and F, what are the stress here? In this case also, stress will be the simple force by area. Here also you will take the stress force by area. Clear? So either in this case, either here force by area. That is the meaning of this first point. But what people say, sir, in this case, net force becomes 0. This force is F, this force is F, so net force is 0. No stress. Here force will be F stress is F by A. Hooke's law is valid only in the linear part of stress strain curve. This curve we have drawn now. In this curve, Hooke's law is only applicable in this part. Up to A only. A to B, Hooke's law not valid. Only up to A it is valid. Up to A. Young's modulus and shear modulus are relevant only for solid, since they only solids have length and shape. So Young modulus and shear modulus we are defining for the solid. Young modulus, shear modulus defined for the solid only. However, bulk modulus we can define for all. Bulk modulus is relevant for the solid, liquid and gases. It refers to change in volume when every part of the body is under the uniform stress. So shape of the body remain unchanged. And here basically your in this one relevant only for the solids. So only solids have length and shape. So their shape can change, and here shape remain unchanged because uniform stress is there. Okay, like if a sphere will remain as the sphere. If a sphere you compress from all the side, will remain as a sphere. If you have a cube, it will remain as the cube. But if cube under the tangential force, under the shear force, then shape will change. Metals have large values of Young's modulus than alloys and elastomers. A material with large value of Young modulus require a large force to produce small changes in its length. Okay, that's why we are using your in the bridges or everywhere we are using the metals actually. Okay, because even though large force will be there, changes will be more or very less, very less. Okay, so this they can ask that okay, why we are making your bridges with the material with higher your Young modulus region is there. A material, this is the region. A material with large value of Young modulus required a large force to produce small changes in the length. Okay, so changes will not be more. They can handle huge tonnage basically. Okay, like okay, a lot of people are going, a lot of cars and trucks are going. They can handle changes. Deformations will be very lesser in that one. In daily life, we feel that material which stretches more is more elastic. Like we say that rubber is there. We feel rubber is stretching more is more elastic. Truth is, rubber is not more elastic. Hai na? Steel and rubber, this question already you know that which one is more elastic out of the steel and rubber? Steel is more elastic, okay? So we feel that material which stretches more is more elastic, but it is a misnomer. In fact, material which stretches to a lesser extent for a given load is considered to be more elastic. Okay. Now, from here, a lot of okay, you can do the mistake. Means more elastic means more stretching or less stretching. More elastic means more stretching or less stretching. Under a given load, more stretching should be there or less stretching should be there. That will be the more elastic. Less stretching, it should oppose. That is the meaning. Okay. So here, in fact, material which stretches to a lesser extent, okay, for a given load, is considered to be more elastic. Okay. Here comes some questions. 4 identical columns of mile. Take it from the your Miss NCERT exercise. 4 identical hollow cylindrical column of mild steel support a big structure of mass. This is from the bridge, and they have given that inner radius and outer radius. So we can say this is the outer radius, this is the inner radius. So solid part is only in this part, here only. This one is going to support. Total load is 5 of this, and 4 pillars are there. So total area will be basically here. I can say for each pi R2 square minus R1 square, outer minus, because solid part is present only in this, not in the your hollow part. Pi R2 square minus R1 square, but there are the 4 pillars, so I can say total is the 4 pi R2. And they are asking what are the strain here. In this one we have to find. So first we'll find the stress. Stress will be simply equal to force by area. Force is actually 5 into 10 power. In this one 4 into G is 10 divided by, we can write here 4 pi R2 square minus R1 square. Once you got the stress, then we can say your Y is basically equal to stress by strain. Y will be given when they will ask the question. Y will be always given to you. Clear? Okay. Then comes second question. A piece of copper having in this area is given here. So this is the area given to you. And they are asking force is also given. They are asking what are the strain. Same way, force given, so we can say this force by area will be the stress. And then we can figure out the strain. Steel cable with a radius of this question I will say with radius given here supports a chair lift at sky area. If the maximum stress is not to exceed, means this is the breaking stress or the maximum load it can support. So we can say here in this one, I will write breaking stress is actually equal to F max by A. So from here I can say F max we have to figure out, which will be equal to Bs into A. Bs in this case is given, that is the 10 power 8. Area is, radius is given, so we can use here pi r square. So pi r square, so we can say it becomes 1.5 divided by 100. I need to write into whole square. Calculation you will do, okay? Clear? Okay. Then comes a rigid bar of mass is supported symmetrically by 3 wires, each this much long. Here only I will say the concept. It is the simple question. One is this, and one is here. Okay. 3 wires are there. Out of this, okay, at each end are copper, middle one is the iron. This one is the iron, this is the copper, this is also copper. In the exemplar also this question is there. In the exemplar they have given in the means variable terms. Here they have given the numerical terms. Determine the ratio of their diameter if each have to same tension. So tension is same. You know that here in this pen, if this bar is supported, then elongation will be same or different. First of all, elongation is going to be same or different. Elongation how to be same is elongation of the copper will be same as elongation of the iron. Elongation formula is FL by AY. FL by AY for the copper will be same as FL by AY for the iron. Force is same, length is also same. Force same, length also same. Okay. So basically we can say AY of copper equal to AY of the iron. So we can say ratio of the diameter. So area of copper by area of iron, okay, will be basically equal to Y of iron divided by Y of copper. Okay. Clear? In the example, it is given in terms of variable like this. Radius, so we can take the root. Can we solve? Okay. Now we have mechanical properties of fluid. First question comes from here. It is 2 thigh bones are there and they are going to support the total. Then we have to figure out, so we can see your area of each is 10. So total area becomes basically 20 centimeter square, which will be the 20 into 10 power minus 4. And then they are asking, so pressure, average pressure will be equal to your mg by A, which is the m 4 into this 10 divided by area is 20 into 10 power minus 4. Okay. Clear? Basic question, simple question here. Now, then they are asking what are the pressure on the swimmer 10 meter below the surface of lake. You know, pressure on the swimmer basically will be given by the both the pressure P naught plus rho GH. You know? So we can write here at surface, this is the P naught, but at the depth we can see it will be the here we can write the P naught plus rho GH. Okay, so we need to calculate both. Here P naught we can say this is the 10 power 5. Rho GH we have to take, rho is 10 power 3. G is given here 10 H 10. So we can say 10 power 5, 10 power 5, this becomes 2 into 10 power 5. Okay. And 2 into 10 power 5 is nothing but the 280 amp. Okay. This one is the density of atmosphere at sea level is this. And they're asking how much atmosphere will extend. Okay. What is the maximum height of atmosphere? Atmosphere maximum height is 8 kilometer. They can ask another question here, that up to what height your aeroplane can fly. Change. Okay. We need to change Now, this is the question that they are saying what are the maximum height of atmosphere or up to what height aeroplanes will fly. Aeroplanes cannot fly beyond this 8 kilometer. We can see, suppose this is the earth, here atmosphere is there, okay? Here atmosphere not there. So we can say this is a zero. And because of this one, how much pressure will be there? That is your rho g h. So this rho g h is nothing but the 10 power 5. We can put the values, whatever given here. So this one we get around 8 kilometer, okay? So almost 8 kilometer, because in the reality density of the air will decrease with the height, okay? So not exactly 8, almost 8 we can say. Then we have this question, what are the, at the depth of this in an ocean, what are the absolute pressure? So absolute pressure we can say, simply we can calculate P naught plus rho g h. Then they will ask what is the about the gauge pressure. Gauge pressure is this, rho g h is known as gauge pressure. This is the your gauge pressure. Absolute pressure is P naught plus rho g h. In the first one they are asking P naught plus rho g h. We can calculate gauge pressure is simply your what? So we can say total pressure is 104. Out of that 1 atm is already included from the atmosphere. So this becomes 103 atm. Okay. Then they are asking that, okay, in this one, the force acting on the window of area, this is the area given here of submarine. Okay. What are the force acting? So we can say total pressure we got in the, okay. So pressure inside, outside the submarine is how much? We can see suppose this is the submarine here. Outside pressure is how much? 104 atm. Inside pressure is how much? 1 atm. So what are the pressure difference basically? 103 atm is 10 power 5 into this area, which is the, okay, 20 into 20 means becomes here 400 into 10 power minus 4. Okay, this is the force on the submarine. Question appears like tough, but nothing is there. We can say this is the force, means there's a pressure into area here. Now we have next question. Two syringes of different cross section, okay, of different cross section filled with the water are connected, okay, with a tightly fitted rubber tube with the water. Diameters of the small piston and large pistons are given 1 and 3. Now find the force exerted on the large, okay. So you can say pressure remain same here. This is from the Pascal actually. So we can say F1 by A1, okay. Actually here in this one we need to write, since pressure is transmitted undiminished throughout the liquid fluid, this is the statement of Pascal's law. We can say F1 divided by A1 is actually equal to here F2 by A2. They are asking F2, so we can say F2 will be equal to here A2 by A1 into F1. Then just putting the value pi will be cancelled, a lot of things will be cancelled. We got here, okay. Then they are saying find the force, means in the second part, if the small piston is moved by some distance, then how much it will move. So we can say, here we can use L1 A1 equal to L2 U2, or a simple equation of continuity we can use in this one. That is the A1 V1 equal to your A2 V2, okay. In the same time, so we can say this becomes A1 into L1 equal to A2 into L2, okay. Both you need to remember. Then this is again from the Pascal. They are saying a car lift compressed, okay, air, okay, and they have given this is the your force F1. Radius is given 5, and okay, piston radius is given 15 here. Mass of the car is this. We say 1350 into G, which is the 10, divided by we can say piston is 15. So we say pi into here 15 into 10 power minus 2 whole square. This side we get F2 divided by pi square. Now you can do the calculation, because you can say pi will be cancelled. This 5 becomes here 3. 10 power minus 2 will be cancelled. So it becomes actually F2 equal to, in this one, 13500 divided by 9. Okay. This much is the force required here. Clear? Okay. We can just divide, same answer coming here. Now, This is the one already asked to you. I think you already have done this one. We know whenever Bernoulli questions are coming, aeroplane questions are coming, always you have to use this one. Delta P equal to half rho, okay, in this one V1 square minus V2 square. This is the formula you have to remember, or we can say V2 square minus V1 square. Which one is more? Okay, more minus less you have to write. Okay, so they are asking this one, what is the delta P? So if they are asking the delta P, estimate the pressure difference between lower and upper surface of the wing. So we guess we'll use this formula multiple times. We'll use, and for the calculation you will always say 1.2. But here we can write V2 plus V1, V2 minus V1. So this becomes actually here V2 plus V1, and other bracket we can write V2 minus V1 for the calculation purpose. Okay, and then do in this. Okay, can we put the values? Okay, but here in this one, this is not needed actually, because they are saying it is in the level 5. So you know this delta P should be equal to actually mg by a. So first of all, you have to calculate the delta P. They are saying it is in the level 5. Means at a level it is fighting. At a level it is fighting means it is not going up or down. Stationary means it's whatever pressure difference is there, that should be balancing the weight only. So mg by a, m is here 3.3 into 10 power 5 into g is 10, area is 500. This is the delta P first of all. Okay, so delta P is get by 3.3 into 10 power 5 into g, 9.8 they have taken, we'll take always 10 by a. We got this. After they asking your delta V, this one we can say the delta V, and this one we can say the average speed. Okay, average speed is given how much? 960 kilometer per hour. V2 plus V1 by 2. This thing we can say the average speed. So this becomes basically your 1.2 delta V divided by, okay, and this is the your V average. Okay, V average, and then we can calculate what is the delta V, fractional. Okay, delta V means relative change in the upper and lower. Comes this question: a fluid flows through a pipe of cross section, diameters given 2.5 and 3.75, ratio of velocity. Here again we have to use the same relation, a1 v1 equal to a2 v2. So we can say v1 by v2 actually becomes in this one your a2 by a1. This becomes here d2 by d1 whole square. Okay, d2 by d1 whole square. Clear? Possible? Solution also given. Easy question. Then we have next one. In a test experiment on model aeroplane in the wind tunnel, we always test in the wind tunnel first of all in the, okay, the flow speed on the upper and lower are this. What are the lift? We'll use the same formula here, delta P equal to, which is the half rho V2 square minus V1 square. So we can say half rho here V2 plus V1, in the other bracket V2 minus V1. Okay, we can put the values half. Rho is 1.3. V2 plus V1 means this becomes 133, and here becomes 7. This is the delta P. Okay, they're asking what is the lift. So if you need to find the force, then force will be equal to simple delta P into A. You got the force also. Clear? Okay. This is the question of the viscosity. Only single question is taken here. Language given. This is the diagram. We know we have to use the formula F equal to eta A dV by dx. How much force is there? This is the force basically. So we can say this force is going to be mg. So mg basically in this one becomes how much? 0.1 Newton. So force is the 0.1 Newton here. Eta we have to find. Area we can write, okay, I think area is given here. This is the 0.1. Okay, so area 0.1. dV is the relative velocity, whatever given. It is given in this one. Velocity is 0.085. 0.085 divided by thickness. What are the thickness here? This is the given. Okay, liquid filled with a thickness of 0.3 mm. So 0.3 mm means 10 power minus 3. Can we get the eta value here in this one? Is it possible to get the eta? Okay. Now, this is the question on the terminal velocity, formula of the terminal velocity. I'm writing, calculation you will do because time is also approaching fast. Terminal velocity formula is this 2r square g rho s minus rho l divided by 9 eta. Okay, all the values are given here. Just you have to keep these values, get the answer in this one. All the density given, everything formula need to be remembered here. Okay, now this is the your question from surface tension. They are asking about the excess pressure. Question is big, but its solution is very simple. Okay, they're asking pressure inside the bubble. We know if any bubble is this is the capillary. In the capillary here we have to make the bubble. Okay, so you can say now this bubble. Okay, this bubble here, liquid is there. Okay, so how many layers are there? Because this is the one mistake people can do. Okay, in this one, how many layers will be there? Simple, one layer is there, na? One layer. So we can say here a pressure is P naught. Then what is the pressure here? So here somewhat more. So this is the P naught plus 2T by R. Okay, so this pressure is. Here we can do the mistake by taking, because you will see the bubble is there. Bubble means basically 40 by R, not all the time. Okay, here we'll take 2T by R. So this question you have to see. Clear? It is written also. Okay, the excess pressure in a bubble of gas in a liquid is given by 2T by R, 2S by R. Okay, you should note there is only one liquid surface in this case. For a bubble of liquid in a gas, there are the two liquid surface. So the formula for excess pressure in that case is how much? 40 by R. This question only taken for that here you have to take 2T by R or you have to take 40 by R. Calculation is nothing. Just this thing you have to keep in the mind. Okay, so this is your bubble of gas in the liquid. Okay, air bubble. So for the air bubble you have to take all the time. Air bubble you have to take always single layer. Air bubble is the single layer you have to take. Okay, air bubble or gas bubble. Okay, gas in a liquid 2T by R. Okay, soap bubble or something, then we take the 40 by R. This is the one thing that is important here you need to know. Okay, in this one we consider three interfacial tensions, all the three interfaces. Liquid air, so we can see one interfacial tension will be here in the liquid air, one will be in the solid liquid, and one in the solid air here. Okay, if we take the component of this, then we can say this will be here your along this one as LA cos theta. If I balance, then we can say as SA is basically equal to as SL plus we can write as LA cos theta. Okay, so this is written here. You will always use this one, whether it will be your acute or obtuse. From here we can write cos theta becomes actually equal to as SA minus as SL divided by, we can write here as LA. If SSA is more than SL, solid air is more than solid liquid, then this value will be positive. So it will be the acute, otherwise it will be the obtuse if this one is more. If solid liquid is more, okay, then molecules will be attached with the, okay, so it can be obtuse. So acute or obtuse is decided by this formula. Clear? So you have to remember this one, that SSA equal to SL plus SLA cos theta. I cannot give more time here. So you will read this one, you will give one reading. I just marked that you should know this thing. Interfacial tensions, SSA minus SSL. Coming from here, very simple derivation is there. And acute and obtuse, you will decide from here. I cannot give more time to this one. You will read one time this thing, okay? In the whole surface tension, this is the one thing that you ignore. Already, okay? You also know by this time, a lot of people even don't see what is this thing. This is the from NCRT only taking. And a lot of people, already I asked one time this question also in the examination. And you have not done. So you will read this thing again, okay? Then comes here your, in this one, points to ponder actually. Gauge pressure is the difference of actual pressure and the atmospheric pressure. Here we can say many pressure measuring devices measure the gauge pressure. These include the tire pressure gauge and the blood pressure gauge, okay, like this. Many pressure measuring devices measure the what? Gauge pressure, okay, like these include the tire pressure or blood pressure, okay. So that is the gauge pressure, not the your total pressure. Gauge pressure is the difference of the actual and atmosphere. Atmosphere we are subtracting. Streamline is a map of fluid flow. It is the in a steady flow, two streamlines do not intersect, as it means the fluid particle will have two possible velocities at that point. So they cannot intersect. Bernoulli principle does not hold in the presence of viscous drag on the liquid. For the Bernoulli, it should be non-viscous, okay? Non-viscous ideal liquid, okay? That is valid for ideal liquid. Work done by this dissipative force must be taken into account in this case if it is there when you are using the Bernoulli. And then as the temperature rises, the atom of liquid become more mobile and the coefficient of viscosity falls. Means if temperature, summary I will say here for this one, temperature more, viscosity will be less for liquid, okay, and for gases, temperature more, viscosity more for gases, okay. This is the conclusion of this statement, okay. And surface tension is property of, okay, property of single, it is not the property of single fluid alone, it is the property of surface. And at the surface there are always two liquids, means two mediums. So it is not the property of single fluid. Proper surface tension is not the property of single fluid alone, okay. Now here we got this scale that you have to remember already. You know that in this one, what are the ice point, what are your absolute zero? Absolute zero, you need to know 0 Kelvin here, 273.15 here. This, okay. Now, so I will not say much things about your scales. Then a change in the length, change in the area, change in the volume. Everyone knows here alpha delta theta, here 2 alpha delta theta, here 3 alpha delta theta. This is the one graph you need to remember about the your volume expansion coefficient of copper. Whenever any fixed graph is given, we need to remember. So volume expansion of the copper is this. Fixed graph is this, okay. Need to be remembered. Then we have here in this one, what happens by preventing the thermal expansion of rod by fixing its end rigidly, okay. Is here we are having in this one, this is the rod here and we are keeping like this and we are, okay, preventing it from the expansion. Because of this rod want to expand but cannot expand, so there will be the stress is developed in this one, okay. So we can say here, stress will be developed here. How much stress is developed actually we can say this. First of all, we need to find the strain. Strain is basically delta L by L, so which will be actually equal to alpha delta theta, alpha delta theta. And then strain we got, so we can say your stress H all the time equal to Y into strain. So we can say this becomes Y alpha delta theta, but stress is the force by area, so force becomes Y A alpha delta theta. This is the I have derived the formula. Here all the values are there, just you can put the values, okay. All the values will be given to you, we can put. So you have to remember for the force, this compressive force is given by Y A alpha delta theta. Y A alpha delta theta. Now this is the one important question from expansion. They are saying a blacksmith fixes iron ring on the rim of wooden wheel of horse cart. Diameter of the rim and the iron ring are this. So you know basically that here in this one, this is the, okay, and we will keep our this is the wheel, okay, and we'll keep our rim somewhat small, okay, not too small, somewhat small. Then this one we have to fit here. So we can say in that case delta D should be equal to D naught alpha delta theta. How much we need to, okay, so in this case we can say this is the 5.243 and this is the 5.231. So how much we need to expand? Actually you can say 0.0, this is the 1 2, 0.012 we have to expand. D naught I can say 5.2, all 5.2 rough, I'm taking the approximate. Alpha is given here, that is the 1.2 into 10 power minus 5. Delta theta you have to calculate. What are the temperature change needed? Okay, don't go by the solution of NCRT, you can just go here. Clear? Okay. They are saying sphere of this is, okay, aluminum is placed for sufficient time in the vessel containing the boiling water. Sufficient time, so temperature of the sphere becomes 100 degrees Celsius. It is then transferred immediately to this copper calorimetry containing this much water at 20 degrees Celsius. The temperature of water rises and attains a steady state at 23 degrees Celsius. Calculate the specific heat of aluminium. So we can say energy released, okay, energy released equal to absorbed, okay, energy absorbed. This is the principle we'll use. Who will release the energy? It is by the aluminium. So we can say this is the 0.0, okay, here in this pen 47. So we can write here 0.047 into specific heat. We have to find delta theta will be, in this case, steady state is given 23. So from 100, this comes to 23. Earlier temperature was 100, then it comes to 23. So we can say here in this one, your temperature change becomes here 77. This energy, whatever the energy, this S you have to find, S is the target here to find. This energy is absorbed by the calorimeter plus water. How much water will take? Water is your 0.25, specific heat will take 40 to 100, delta theta will be 3, plus how much calorimeter will take, okay, and this is the 0.14 kg copper calorimeter. So 0.14, okay, specific heat of the copper will be given to you, and then delta 3 we can take here also 3, and then we can do the calculation. Okay, energy released, aluminum will release, copper plus water will take the energy, will absorb the energy. These are the two graphs you remember. Now, in this one, you will remember here, that was not from exemplar, that was not from anywhere, okay? So in this one, this is for water, okay? So this graph you have to remember for the water here. This one is solid to liquid. So solid to liquid means this one is the your melting curve. This one is the your boiling curve, and this is the sublimation, okay? So this is the your solid directly going into sublimation. You remember, this is for the CO2. CO2 no need to remember if you don't want. This one need to be remembered for the water, okay? These three names: melting curve, boiling curve, sublimation curve. Then they are saying when this much ice is mixed with the water in a container, the resulting temperature is 6.7. Calculate the heat of fusion. Calculate the heat of fusion is nothing, because you know that in this case, this side ice is there, this side water is there, and one will take and one will release the energy. Okay, one will be taking, one will be releasing the energy. Will absorb and water will release the energy. Okay, can you solve this one? This question, same previous method. One will release, other will absorb. You will try this one. Okay, I'm leaving this question for you. Now, this is the one question I will solve here. Calculate the heat required to convert 3 kg of ice at -12 to steam. Okay, very simple question. Appears like tough. Don't go by the solution of this one. We can say here this is the ice. Na? Ice. Ice is at what temperature? -12. This will go to the first ice at 0. Ice 0 will go to water at 0. Water at 0 will go to water at 100. And water at 100 will go to steam at 100. Okay. Now, here we have to put the calculations. This is the, first of all, ms delta theta. Here we can say this is the MLF. Here we can write again ms delta theta, and this one becomes the MLV, and put the values. Clear? Can we put the values here? These values are there. We can have to put. Okay. In the notes, you will be having a lot of questions like this. Now, this is the one question. A child running a temperature of 101 Fahrenheit is given an antiparin like paracetamol, okay, which causes increase in the rate of evaporation, okay, and fever comes down in the your 98 minute. Na? So from 101 to 98 minute means what are the delta F first of all? Is the 3 Fahrenheit. But we don't do calculation in the 3 Fahrenheit. We do in the Celsius. So delta F by 9 equal to delta C by 5. So we can say this is the 3 here. So delta C becomes basically 5 by 3 degrees Celsius. This one I will use. Okay. Then we know what will happen basically, that from the body, why evaporation is increasing. Evaporation increased so that temperature can be down, so body is losing the fluid. That's why doctors always put some extra fluid, saline or something, so that fluid will not be, these fluid losses will not happen in the body, fluid will be maintained. So we can say in this, when your body temperature coming down, ms delta theta, it is, okay, this much energy we have to release outside. How will release outside? Basically your MLV, okay, mass of steam formed, whatever, I cannot say the steam, I can say vapor formed, MV into LV, you know? This will be the basically MV into, oh, all cleaned, undo not there. So delta F was basically 3, so I can say delta C becomes here, this is the formula, delta F by 9 equal to delta C by 5, so we got delta C equal to 5 by 3. Then we can say ms delta theta is basically equal to MV into LV. Mass of vapor formed we have to figure out. M, that is the child mass 30. Specific heat they are saying take as water, so we can say here this is the 1. One, and this is the 1 calorie, so I can say this mass I can take in the kg, so 30 into 10 power 3 I have taken the gram. This is the 1 delta theta becomes here 5 by 3, and LV becomes 580, I can say. This is the mass, total mass of vapor, total mass of the vapor. They are asking rate of evaporation. So rate of evaporation is the total rate of evaporation. If they are asking, then we can say rate of evaporation becomes MV divided by T. So MV divided by T. T is basically how much here in this one? That is how much? 20 minutes. So 20 minutes. So 20 into 1 minute is 60. Okay, this is the mass per second. Okay, so calculation is very easy. Body, your body is going to release this much energy because temperature how to be down, so it will be releasing how much energy? Ms delta theta. And how it will release the energy? By losing some of the water content. Vaporization will happen. Evaporation will happen basically. MV into LV. So we can say rate of mass, evaporated mass, total evaporated mass we can calculate here. The rate of evaporation we can solve like this. Now this is the simple question you should try. Okay, from the conduction it is there. Okay, I'm skipping this one. Now this one I have taken here. Thermodynamics may involve other variables that are not so obvious to our senses, like enthalpy is there, entropy is there. In physics, we don't talk about the entropy and enthalpy. In the chemistry, they are microscopic variable. However, thermodynamic state is specified by 5 state variables. Thermodynamic state is specified by 5 state variables like pressure, volume, temperature. Mostly we are using these three. We are habitual of these things, but internal energy and entropy. Okay, these are the 5. Okay, so thermodynamic state is specified by the pressure, volume, temperature, internal energy, and entropy. Entropy is the measure of your disorderness. Enthalpy is the measure of total heat content. Okay, clear? So thermodynamic may also involve other variables that are not so obvious to our senses. So thermodynamic state is specified by 5 state. Okay, and these are the pressure, volume, temperature, internal energy, as well as your entropy. Types of process, already we know isothermal temperature will be constant, isobaric pressure is constant, isochoric volume is constant, adiabatic net heat exchange is 0. Then this comes one question here that we know in the first law Q delta Q equal to delta U plus P delta V, and they are asking here one question that we have here. Okay, that when water goes to steam, okay, so 1 gram water will form, 1 gram is basically 1 cc, will form 1671 cc of steam. 1671 cc of steam. So they're asking that how much work. So work we can say there with a P delta V basically. So we can say P V2 minus V1. So we can say here in this one that the 10 power 5, this becomes 167. And I can say like this also, because this will be the 1.67 into this, because this is the cc, so 10 power minus 3. So now you can see this becomes actually here 167 joule, which is the 40 calorie. Okay, this is the work done. Then we can find Q. Q is simply going to be MLV. M is 1 LV will be the 540. So this becomes here 540 calories. So we can say delta U, which is the Q minus W. We can say 500 calorie. Why this question is important? Because a lot of time they will say that during phase change, this is the, okay, during phase change, so during phase change, temperature remain constant. During phase change, temperature remain constant. So change in internal energy 0. True or false? During phase change, temperature constant, but delta U not 0. Okay, delta U non-zero. We have calculated here. Delta U is 500 calorie. Okay, so remember during phase change, whenever phase is changing, even though temperature is constant, but change of internal energy not 0. Here, this internal energy is basically used to change the phase. Okay, so temperature constant does not mean delta U is 0. It is only 0 for the gases. Okay. These are the 2 questions you have to solve from the marked. Okay, I need to solve, but now okay, time is running, so you will do. Questions are easy from the thermodynamics number 1 and 2. Okay, you will do these questions, basic questions. This question I will do it. They are saying thermodynamic state is taken from original state to intermediate state by the linear process. Here they're asking this one total work. So yes, a total work is nothing but the total area we have to find. And total area we can say this is the half base we can say this is the here 3 liter meter cube is given. So 3 and height becomes basically your 300. That's it. This is the answer here. Okay, area you have to figure out. This is the again question from the exemplar. They are saying a system goes from 2 different paths. Okay, in this one, you know, for the path 1, delta U1 equal to delta U2. So Q1 minus W1 will be equal to Q2 minus W2. They're asking what are the Q2? What are the heat exchange in the path 2? So Q2 we can say will be equal to here in this one Q1 plus W2 minus W1, like this I can see. And they have given that here work done by the system along the path 1 is more, so I can say like this actually here minus W1 minus W2. Okay, like this I have rearranged. Q1 is given how much here in this case? 1000. So we can say this is the 1000. And they are saying W1 minus W2. They are not given W1, W2 separate. W1 minus W2. So that is here given how much? 100. So we can say this becomes 900. Clear? Okay. Now we have here KTG. This is the graph. First of all, you remember at the high temperature, it will approach towards the ideal behavior. Okay. Here we can see this much deviation, here this much deviation, here this much deviation. As temperature will be more, it will be going towards the ideal behavior, means this temperature is less, this temperature is more, this temperature even more. Okay, so here order, if they are asking, then we can say T1 is greater than T2, then greater than T3. At the high temperature, it will approach towards the ideal behavior. Now, this is the one question here. Flask contains argon and chlorine in the ratio 2:1. The temperature of the mixture given. They're asking average kinetic energy per molecule. Average kinetic energy per molecule is 3/2 kT. Okay, as NCRT is saying. So 3/2 kT will use. So 3/2 kT means okay. Here we can say 3/2 kT. So K is constant, temperature is same. So ratio becomes what here? 1:1. Okay. Next one is the VRMS. VRMS simply we can say, we can calculate, because formula of VRMS already you know. A cylinder of fixed capacity 44.8 liter means how many moles are there? You can see here in this one how many moles are there. This is the 2 moles. And they are asking that okay, in a fixed capacity means volume is constant. They are asking amount of heat needed to raise the temperature by 15 degrees Celsius. So we can say Q, I will use here formula, and CV delta T. N is the 2. CV for the helium, I will use 3R/2. Delta T is 15. Can you do the calculation? Calculation can be done. Okay, easy question. This one. At what temperature is the root RMS of atom in the argon gas equal to RMS of helium gas? Okay, so we can see here in this one, your V RMS of okay, AR is basically equal to V RMS of helium. Formula is here root of 3R T1 by MW1 equal to, here we create root of 3R T2 by MW2. Root will be cancelled, 3R also cancelled. T1 is basically, we have to figure out. MW1 we can say 40 for the argon. 39 given, I have taken 40, and T2 is given -20. So you can convert 273, so this becomes 253. Divide by M2, it is the 4. Calculation we can do. This one, a cylinder containing a gas, and they are asking if temperature increased. Now we can say if this is the piston here, pressure remains same. Okay, pressure is going to be same. So if you increase the temperature, then ultimately we can say what? Volume will increase, because V proportional to T here. Okay, so V proportional to T. So if temperature increases, volume increases, V proportional to T. So here we can give V will change, but not the P, as P is fixed. Why P is fixed? Because cylinder atmospheric is fixed, cylinder mass also fixed. Okay, so volume will change, but pressure will not change here. Now, this is the one question coming that okay, already you know, in this case we can just go by this method, that here this is the V, so we can make this thing constant. So we can write this is the T, this is the T2. In PV equal to nRT, we can say nR constant, volume also constant, so P proportional to T. Here we can say T1 is greater than T2, so we can say P1 is greater than P2. Or you can by the slope method also. Slope means lesser slope is always higher. This is the least slope will be the more. Okay. This is a simple question. The PV equal to nRT. Okay, so they are saying that in this one, temperature becomes here PV equal to nRT, or we can say nRT. Volume is fixed. They are saying gas gets converted to the hydrogen atom. Earlier 1 mole. So later on moles will be 2 moles. And temperature 300 to 3000 means temperature becomes how much? 10 times. So due to the temperature 10 times effect, and due to the moles 2 times effect. So total effect will be what? 20 times here. Okay. This is the again exemplar question. These were the exemplar questions. Last year, the same question is there. This is the last year question. As it is. Container shown in the figure has two chambers. They didn't give the diagram. Diagram not needed also. You know, energy will remain same. So if ideal gas is there, then we can say F by 2. For the ideal gas, we can say 3 by 2 P1 V1 plus 3 by 2 P2 V2 will be actually equal to 3 by 2 P, and here we can say V1 plus V2 because we have joined. You know? So energy will remain same. So 3 by 2 we can cancel. And then you can say P1 V1. So P1 is the 1 into 2 plus P2 is 2 into 3 equal to, we can say P. V1 plus V2, we can say it is the 5. This is the 6 to 8. So it becomes 8 by 5, which is the 1.6 ATM. Okay? Clear? Very simple. One-liner question was there. And other question of the KTG was from the exercise. I have not taken that one. Here, okay, you will do it, okay? Now we have here oscillation. This is the first question. That is the human beating. Okay, I will ask one question on this one. So you know 75 times, so we can find the frequency. This is the 75 times in 1 minute. So we will find first of all per second 1.25 and then time period we got. Then this comes. Which of the following function of time represents periodic? So you have to remember that exponential and log are not periodic. Okay. So this one is periodic. This one is also periodic. Okay. These two are the periodic. But out of these, only this periodic is the SHM. Okay. These two are the periodic. These two cannot be periodic. Which cannot be periodic? They are not the SHM also. So exponential, log, these functions not periodic, not SHM. Trigonometric functions are periodic, like tan is there, cot is there. These are periodic, but they are not SHM. Only simple function of sine and cos are the SHM. Like this one is the periodic function, but here frequency is omega, here frequency 2 omega, here frequency 4 omega. Frequency must be same. When frequency is different, they cannot be SHM. So even though the second one is the periodic, but not SHM. Okay, SHM is only one. Frequency must be same. Like here frequency omega, here also frequency omega. When frequency is same, then we can say yes, it is the SHM. They have given this circle type questions. Whenever circle type questions are there, they are asking that what will be the answers here. I will solve. Always, if they are asking answer in the X, you will draw line along the X. If they are asking the Y, you will draw along Y. Okay, like this. So what we can do basically that this is the your 0. After some time, we can say that suppose it comes here. It is moving like this. So it will move how much angle here? Theta. So you can say basically that this is the your X. This is the Y plus Y, and this is the plus X. Okay, triangle we have to make. Now we guess theta will be omega t. So we can write here sine theta will be x by a. So from here we can say x equal to a sine theta. Theta is the omega t. Cos theta we can write like this y by a. So this y will be equal to here a cos theta, which is the omega t. So starting from here, then we can say it will be coming at this point. So how much it will move? Omega t. Clear? Same way you will do this also. This one is for the practice. Two diagrams are there. Now, a body oscillates with the SHM according to the equation. Okay, this is given at 1.5 second. At 1.5 second, they are asking you to find all the three things. When you will put here 1.5, then this becomes 3 pi. Cos 3 pi is nothing but the 2 pi plus pi. So 2 pi is nothing, you can ignore. So there's a pi plus pi by 4. So pi plus pi by 4 comes this value here. Okay. So once you got the x, after that you have to use, don't go by this method. You will say for the acceleration we can use minus omega square, and velocity we can say omega under root a square minus x square. So don't use the mathematical. Only for the x you will use mathematically. Rest you will go this way. Okay. You will use the formula A equal to minus omega square x, velocity equal to omega root of A square minus x square. They are asking that here in this one, and they are asking what are your time period of this thing. So you know that they are actually, in this case, this is the parallel, when block in the middle, and in the parallel we can see in the series and parallel. So you know in the parallel K equivalent is simply given by K1 plus K2, and here we can say 1 by K equivalent will be the 1 by K1 plus 1 by K2. So we can say for the parallel KK becomes 2K. So T equal to becomes 2 pi root of M by 2K. Very basic question and very important also. Why basic? Because this is the parallel KK becomes 2K and we can take directly. Then these are the graphs you have to remember for the potential energy and kinetic energy. Okay. Like this one is here for the potential energy, inverted one. Okay. We can say for the Amisa, this one I can write here, okay? Like this one is there. So we can say this graph is here, okay? At the extreme position, if you say, then at the extreme position, at the mean position value is what? 0. Extreme position, so there's a graph of potential energy. Inverted one, we can say graph of K. Because at the extreme, it becomes 0. So graph you have to remember. This is the one question. They're asking here that calculate the kinetic potential and total energy of the block when it is 5 centimeter away from the mean position. Amplitude is 10. So basically I can say that amplitude is 10, okay? A is 10 and x is 5 means basically this is the A by 2. So I can say my potential energy will be simply half kx square, and total energy will be simply equal to much half k square. Potential becomes half x square, means which will be the A square by 4. So this will be the total energy by 4. So if you calculate the total energy, then potential will be the 1 by 4th. And kinetic, we can say this will be the your okay. If this is the your total by 4, so this will be the 3 by 4th of total. No need of formula. What are the length of simple pendulum which takes second? Length of second pendulum. Length of second pendulum already we know that is the 1 meter. Okay, length of second pendulum you have to remember that is the 1 meter. This comes here one question. They are saying which of the following relationship would be the acceleration and displacement of the particle may involve SHM. You know A proportional to minus x should be there. So this one not there because minus not there. This one not there. This one cube is there. This one is only possible which is the A proportional to minus x. A proportional to minus x will be the correct answer. Now this comes here when again this is the parallel. Okay, so parallel one is very important here. We know in the parallel your K equivalent is given by K1 plus K2. Time we know T is proportional to, or we can say T proportional to under root 1 by K. And they are asking in terms of frequency, so we can say basically 1 by f. So frequency square is proportional to k. So I can write here in this one that this k equivalent becomes actually f equivalent square, and here we write f1 square plus ft square. This relation with the time period as well as frequency both need to be remembered, okay, with the time period and frequency also. Now comes here wave. First they are asking that the motion of kink in the longitudinal spring. So in the spring both are possible, longitudinal also as well as transverse. When spring is moving like this, then this is the longitudinal. Spring can move this way also, so the transverse. Waves produced in the cylinder. So it will be the basically whenever waves are you are moving the cylinder, then only like this. So this is the longitudinal. Waves produced by motorboat. Motorboat means waves on the surface of water, and the surface of water it can be longi also as well as transverse also. On the surface of water these waves are known as ripples. Ripples are the longi and trans both. And then we have here next is ultrasonic waves. Okay, ultrasonic means ultimately sound waves. Sound wave is the longi. tuned. This is the next question coming. Steel wire of long has the mass and wire is under the tension. What are the speed? You know, speed is simply given by root of T by mu. Okay, this is the formula. Mu we have to find. What are the mu? Mass by length. So calculated here, mu is mass divided by length here. So we got the mu, and then we can put here T by mu. So 60 by 6.9 into 10 power minus 3. Can we calculate? Important and easy question. First we have to get the mu. Mu is the mass per unit length, and then we can write T by mu. Clear? Now, then we have next question here. A pipe 30 centimeter long is open at both ends. Which harmonic? You have seen this question multiple times in your examination. It resonates to 1.1 kilohertz source. Now in this one, first of all, we need to figure out here its fundamental. So we can say it is open at both ends. So fundamental is going to be here V by 2L. Okay, don't go by the solution of NCERT again. V by 2L you have to calculate. V is in this case given, that is the 330. We can say 330 divided by 2, and length in this case is length is 30 centimeters. We can say 30 by 100. You will calculate this one 0, 0. This becomes here 11. So this becomes your 550. 550 is the fundamental, and they're asking what is the 1.1. You can say one is the 550, next will be 2 times of this one, means what? 1100. So 1100 is the basically what? Second harmonic. Okay, so we can see will resonate with second harmonic here. They can ask with for anyone. Then this is the 2 sitar strings A and B playing the note dha are slightly out of tune and produce frequency of 5 hertz. Whenever these questions are there, whatever known frequency is there, frequency of A is known to you, 427. So you can write A is the 427. So we can say possibility for the B here, we can write there are the 5 beats. So we can say this becomes 432 and this becomes 422. Now we are putting in we are doing basically tension in the B is slightly increased. So here you will do the like this, tension increasing means arrow will be up. Now you know this one is saying that here difference is going to increase. If answer is 432, difference keep on increasing, and with the 422, because 422 will become like 423, 424, so difference will decrease. So they are saying here beats are 3, and beats 3 are only possible with the 422, not with the 432, because with the 432 it is always going to increase. Now, this comes one question again from the exemplar here. They are giving that equation of plane progressive wave is given, and reflection from a denser medium, its amplitude becomes 2 by 3. So first of all, we can say reflected wave, if our right amplitude will change. 2 by 3 means this becomes 0.4 sine 2 pi t plus x by 2. Then we have to decide whether there will be the phase change or no phase change. Reflection from the denser, I need to add here pi. And you know, whenever you will add the pi, there will be the minus sign here. So it becomes minus 0.4 sine 2 pi t plus x by 2. Why this minus is coming? Because sine pi plus theta is going to be minus sine theta. Now we are, okay. A string of mass 2.5 kg is under tension of this. Then the length of each 20 meters. So first of all, what you will find? You will find the mu. So mu basically becomes 2.5 divided by 20. 2.5 by 20, if you solve, this becomes 0.125 kg per meter. Then we will find the speed, which will be the tension by mu. So 200 divided by 0.125, which will be root of 1600, which becomes here your 40 meter per second. They are asking in this one, we have generated here how much time it will take to reach other end. This time will be simply here 20 divided by 40, and this time is going to be your half second in this one. Done? Okay, so in the wave, basically we have taken not more question of the exemplar, only we have done the NCERT. Okay, so you can 3-4 questions are taken from the exemplar. Now it is closed. You will revise all the things, all important questions taken, some of the important questions